of a safety instrumented system, our Purdue model modal module defeathers and plucks clean every proverbial fox in the henhouse and keeps would-be intruders wondering which metaphor got mixed first. As you can see, the hyperencabulator has reached a high level of development. Whereas previous dissimilar devices operated under the concept of manumatic stressor reduction and macroeconomic supply chain SBOMs, the hyperencabulator operates totally under the principle of colonic effluvium expulsion and audible gaseous eructations. Thomas Edison once said that invention was 10% inspiration and 90% perspiration. If that's the case, Thomas Edison should have invented deodorant, but I regress. In the near future, hyperencabulation will ultimately replace all traditional cybersecurity safeguarding processes with osculating segmentation and entropic astrogation, making what was once thought to be impossible, probable. At SANS ICS Security, when we're not innovating, we're encabulating.
Did you like that? Did you like that? Good? Well, you shouldn't. Here, I got another one for you. You'll like this one. This one's for real, though. I'll be back in a moment. I'm just going to cook some food.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the Sun at one focus and the other focus empty.
applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas, states,
the line joining the planet to the Sun sweeps over equal areas in equal time intervals.
When a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the Sun to its mean distance from the Sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the Sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the three Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any two objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not zero, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a 3-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the two nodes is called the line of nodes. The orientation of an orbit is determined by 3 orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The 5 orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the 6 orbital elements. The 6 orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are 2 causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about a half degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch, measured eastward from due north, is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees. This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the space shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the space shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The space shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 space shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system referred to as OMS are required to place the orbiter in its final orbit. The OMS 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The OMS 2 burn takes place approximately 30 minutes later and circularizes the orbit. Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft. Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime. On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's velocity and are known as posigrade burns. With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of two burns and is used to accomplish an orbit transfer between two circular orbits in the same orbital plane. The most energy-efficient transfer between two orbits of this type is the Hohmann transfer. The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other. The burns occur at the perigee and apogee of the transfer orbit. The use of the Hohmann transfer minimizes the delta V required, thus having the advantage of using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer. The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, a satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low-inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special type of geosynchronous orbit with an inclination of 0 degrees is called a geostationary orbit. It appears to hover over a fixed point on the Earth's surface at the equator. Most U.S. communication satellites are in geosynchronous orbits, providing near worldwide communications coverage. For effective communications at high latitudes, the Molniya orbit is used. Molniya is the Russian word for lightning and is an orbit used extensively by the Soviet Union for its communication satellites. The Molniya orbit is highly eccentric with an apogee that is near the geosynchronous altitude and an inclination of about 63 degrees. The satellite slows down at apogee in the northern hemisphere and whips through perigee in the southern hemisphere. This provides communications in the northern hemisphere for up to 75% of its orbital period. Several satellites properly spaced in Molniya orbits can provide constant communications at the northern latitudes. Navigation satellites, such as the U.S. Navy's Transit System and the Joint Service Navstar GPS Global Positioning System, use lower orbits so that a user can receive signals from more than one satellite at any time. Another frequently used orbit is known as a sun-synchronous orbit. These take advantage of the precession of the orbital plane caused by the Earth not being a perfect sphere. All sun-synchronous orbits are highly inclined retrograde orbits which precess eastward around the Earth's polar axis at the rate of 1 revolution per year. Since the Earth-Sun line also revolves eastward at the rate of 1 revolution per year, the orbital plane will maintain a constant orientation relative to the Earth-Sun line. If the satellite's period is then synchronized with the rotation of the Earth, it will pass over the same point on the Earth's surface at the same local time at a regular interval. A sun-synchronous satellite ensures that a constant sun angle and uniform lighting exist for the same field of view from pass to pass. Satellites such as those in the Defense Meteorological Satellite Program and Landsat are sun-synchronous, imaging the entire Earth on a regular schedule. The gravitational attraction of the Earth on a spacecraft causes it to move in its orbit around the Earth. There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the Space Shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
Well, wasn't that nice? Well, wasn't that nice? That was nice. That was good. That was great. All right. Bing bong. Yeah, no, that's the video that I mean, that video's been up on YouTube for actually when I first saw this. Oh, I was about to say this is what I used to learn orbital mechanics back in the day, and then I realized that this video was brand new when I first looked it up, and I had a little bit of a oh. This video's been up on YouTube for 11 years almost. Well, yeah. Yeah, the video's from 1989. Yeah. Okay. All right. Puppet, 48-month resub. You son of a gun! I'm in! You were in high school when that video was uploaded. Yeah, I wasn't in high school. I was out of college for 3 years when that video was posted. Out of college for 3 years. What the hell is wrong with me? Mom and Dad were perfect, but still you don't hear no crying, whining for me like it seems to be on everybody's CD. So just sit back and relax and let me have your head for a minute. Okay. Sorry. You guys want Starship news, don't you? Yeah, alright. Hey, Rarest, 54-month resub. Also, real quick. All morning launches for you, sir. I'll just check rocketlaunch.live. Let's see. I also have to sneeze. The blow-off valve, it's coming. Okay, so I did do a little bit of a bonus stream yesterday where we did talk about kind of the basics of what's going on with the PEA. Now, I haven't reviewed the whole thing, but I haven't reviewed the whole thing, but it's not that. There's no, long story short, well, I mean, I suppose we'll just jump right into the Starship stuff. Long story short, the programmatic environmental assessment did come out yesterday for SpaceX that basically grants SpaceX permission to launch orbital flights out of Texas. First orbital flight ever to fly out of Texas ever. The programmatic environmental assessment that the FAA was doing returned a finding of no significant impact. So it's called a FONSI. But there were, I believe, 73 mitigations. So mitigations are basically the FAA saying, we will find no significant impact as long as you do this. And there's a list of things that they have to do. Do we need to go over the entire document? No, we don't. I read through a good deal of it. Actually, that's the next thing that I was going to say. I read through a good deal of it, guys. It's just small stuff like make sure you don't disturb a bird's nest or something. Adopt an ocelot. Yep. So there's a couple of things that are a little strange in there, but whatever. It's okay. It went through. Mitigated finding of no significant impact. Or modified. Damn it, I did a two-signer. Why can't we just say FONSI? Just say FONSI, alright? Maybe just say it's modified. If people want to know that information, they'll go look it up, okay? Shh. NSF now has bird cam. So what are the next steps? The programmatic environmental assessment was a big hurdle to overcome. If they figured out, like, if they figured out that SpaceX was if they figured out that SpaceX was polluting in some way, shape, or form, they would have to redo an environmental impact. They would have to redo the environmental impact or say that they need an EIS done on Starship, but they don't need to. Now, why? Why is this the case? So I did a little digging around, and you guys tell me if I'm wrong. So there were two basic, there's two basic outcomes here for the programmatic assessment. Basically, the long story of this is that SpaceX was testing Starship down in Boca Chica. We saw stuff like this happen up here, which were probably some of the coolest things I've ever seen, the coolest things that the space community has ever seen. That is so ridiculously neat. But their original programmatic environmental assessment, or actually it was an environmental impact report. The original EIS that was done for Boca Chica was for launching Falcon 9s, and not a very lot of them. That's why SpaceX bought Boca Chica in the first place. That's why they bought all that land. They bought all that land to build a Falcon 9 launch pad, and they bought all the land around it to make sure that no one goes near it. The reason why they did that is basically because they saw a need to build way more launch vehicles. Or they were trying to basically do what they're doing right now, not build more launch vehicles. Reuse more launch vehicles is the right way to say it. Sorry, I didn't say that right. So SpaceX at the time thought with Pad 40, Pad 39A, and Slick 4 that they weren't going to be able to keep up. Turns out that they can do that just fine. So SpaceX in 2018 started using it for Starship research and development. And then they started flying Starship and started popping off test articles. And people were complaining because Starship is supposedly a different launch vehicle. I mean, not supposedly, it is a different launch vehicle. And they said, "Oh, you gotta redo this. This isn't what we tested the environment for." Turns out that rockets are, for the most part, rockets. Yeah. This finding of no significant impact basically says that the original programmatic assessment from the original PEA that was done on Boca Chica for Falcon 9 is not going to be that different than Starship. It's not that different overall. I mean, obviously there are some huge differences, like an entire production facility. And that's, I think, the reason why they wanted to do the PEA, because SpaceX was never really... they never really built a factory, right? They just put up a bunch of tents. So they needed to figure all that stuff out. And this basically shows that It's going to have minimal impact on the environment around it. I mean, obviously, if you build a house somewhere, you're going to screw with the environment in some way, shape, or form. But there's no significant impact, the Rio Grande Valley, which is good. That's a good thing. With that being said, SpaceX did take off a lot. They did take off a lot of things and plans that they had for Boca Chica. Like, this is just speculation on my part. I have no way to prove this. I would be very doubtful if they ever built a second pad at Boca Chica. I really don't think they're going to. When is someone going to tell EJ he's wearing sunglasses inside? That's all I used to do. Anyway. Well, that and this will be the first 100% commercial orbital launch site, so it was set the bar for all future commercial launch sites. Correct, Porter. Actually, I've been reading through a little bit more. They basically copy and pasted the template for the EIS at the Cape, which was already done, and then applied it to the local ecology. So it's basically the Cape's environmental impact, right? Which is already approved, and they just did this one for Texas. But yeah, there's also that. So here's the thing: if the original Falcon 9 programmatic assessment was fine, why is this one? Why did this one take so long? Well, one, because people complain. Two, because you want to really make sure you understand. You want to really make sure you understand the impact here. Because you don't want to just throw around commercial spaceport licenses like they're candy. That's probably something we should be careful with. Just saying. And you know, as screwed up as it sounds, you got to understand where you're building. You got to understand the environment. You got to understand the local ecology. Like, environmental impact surveys aren't there just to appease tree huggers, guys. As much as we all want to think that. They're there to make sure that your factory doesn't fall into the swamp. Or you're in a flood zone. Because, ask anybody that owns a home, flood insurance is expensive. Yeah, flood insurance. Expensive. Very expensive. So, you really want to make sure you don't build your launch pad in a flood zone. Etc., etc. It's required in some places in Arizona. Yikes. Isn't Arizona a desert, though? Rotating caps. Yeah, I'm just using dark mode on the stream. That's why I have sunglasses on. That's a good point, Signer. That's a good point. So, don't forget the flood insurance doesn't cover hurricane flooding for some reason. Yeah, let's just split up all the insurance. All right, fine. If your house has the potential to flood, you can't actually get flood insurance. No joke. In the UK. I can picture that in my head. Oh, I won't build a house here, mate. Oh, you can't build a house there. It's going to flood with water. You can't build a house there, mate. You can't do that. I'm going to build it anyway. Fine, you ain't getting flood insurance from me then. That's probably how that went down. In the US, you have to, or else you're gonna wind up with a boat. House. Yeah, so you guys, I don't mind that the FAA took this much time. 6 months is nothing on the scale of spaceflight. That's nothing. And that's even more nothing for SpaceX. It's not that big of a deal. So I think it's good. All the T's are crossed, all the I's are dotted. And because the FAA said that the programmatic assessment was good, it really protects SpaceX from legal recourse. So, like if another thing like SN11 happens, people can't go after SpaceX. SpaceX is abiding by the rules, and they are conforming to the rules, and they have been doing that, and they've been making the changes over time. They've been working with the FAA, just as I said. That was absolutely 100% right. I don't know why people didn't think that was going on, but whatever. Here you have houseboats. Yeah, because half of your country is underwater. You should have submarines. So, where do we go from here? Besides, they weren't really ready to launch yet. Linux, I think they were ready to launch, but they were probably ready to launch with like Booster 4 and Ship 20, which, yeah. I think once SpaceX realized that an environmental survey needed to be done, and that they were going to hold their, the FAA was going to put their feet to the fire, I think they said, fine, we'll retool anyway. And in that context, I think you're right. I think they would have been, had this not been a thing, they probably would have launched a Starship late last year, if I had to guess. But it wouldn't be the version that we see now, that's for sure. They would not have been ready with the version that we have now last year. No way. In that regard, I very much agree. So, what's next? Next is licensing. They got to get a launch license from the FAA. Phil, you read my mind there. Yeah, then came the chopsticks. Yeah, yeah, exactly. I think they were just going to try to send one off the pad, and then when they realized that it was going to take 6 months for, well, not 6 months, this was in like September of last year. When they realized at the time that it was going to take 4 months, they said, all right, fine, let's build a new version. We lost the meme 420 launch, and it's a shame. It's a damn shame. That's what I think they kept going with Ship 20 and Ship 21, because they wanted to send those and do hypersonic tests with them, but yep, that didn't happen. So now we have, what is it, 24 and 7, and then 25 and 8. Yeah. But SpaceX needs to get the licensing. That should, I don't know, month or so. They already have the FCC stuff filed, because SpaceX is good at doing their homework. So, yeah, and 24 and 7 and here, check this out. 24 and 7 and 25 and 8 are not me. That's the meme lord himself saying this. So check this out. Don't build moats, build tech trees. And you will read this last, you will read this first, and then you will read then this one. Oh, did I not do... Oh, yep. Nope, I didn't do that right. Okay, cool. I don't know what that says about me. You were tricked. I read that. All right. The hierarchy. Okay, so here we go. When's the shit? Yeah. Okay. Thanks for that one, Brain. Did this part right. Can't read correctly. Thanks, Brain. When is the orbital flight happening? Is July possible? Starship will be ready to fly next month. I was in the high bay and mega bay late last night reviewing progress. And then we will have a second Starship stack ready to fly in August, and then monthly thereafter. Holy shnikes. Come on. 4th of July launch. Let's go. Hey guys. Hey guys, you want to see somebody that's not using their brain? Looks like Starship has a limit of 10 launches per year. Okay, what month is it? So, July, August, September, October, November. January, February, March, April, May, June, July, August, September, October. Because, you know, there's that whole year thing. They could launch a Starship every month for the next 15 months, and it'd be fine, because we're halfway through this year already. Our safety guy says they aren't going to get a license to land super heavy on land because of safety thresholds in 29 CFR 450.101. He said Starship, then Starship stack, so 5 of each. They can't launch on the 4th of July because that's a public holiday and they can't close the road during that day, right? Yeah. So they should launch on the 5th. The 5th's a good day. I like that day. Yeah. The 5th's a good day. I like the 5th of July. It's one of my, that's my favorite day of the year. You prefer July 2nd? Yeah. Imagine putting your birthday before this country. That's a shame. All right, so Staples, you don't think they're gonna get a license, huh? Interesting. The 4th of July in French, 3rd of July here, yeah. To land. Is this just what a guy thinks, Staples, or are we on to something here? I think they'll get it eventually. I mean, just don't put people near the pad. Is this complicated? Like, what's the safety issue exactly here? Obviously, we're screwing around with something that's quite large. You have to be far from people. I mean, wouldn't that be the case if they were like landing even like something like New Shepard or birds flying into the engines? It's a rock. Okay. Could ditch in the water. Oh, Primo's calling me, guys. Give me 1 second. I'll be right back. Okay, I'm back. Brimo had to go to work today. Commuting to work. And I locked the door. Should I go let her in? That's why Falcon 9 had to do landings in water first. Yeah, of course. But don't we have Falcon 9 to learn from in that regard? You better? Alright, fine. I commute to work, boss, just not very far. Oh, Tessie, you're so witty. Oh, man. No. Chat was like, no, don't let Brimo in. Why would we want Brimo here? I'm not lying to you. You brought me cupcakes? Oh! I'm just kidding. Okay, have fun. Ugh. Cupcakes. All right. Where were we? You want to change the oil in the bus while we're under it? Yes, I do. Somebody said cupcakes. She brought cupcakes. So, how much stuff did you get packed? Yes. See last. Did you pass, Grav? You wouldn't be telling me if you failed. Let me see. Collective risk threshold. Yes, 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 yes. Great news. I got my temp driver's permit while I'm waiting for my hard copy. Bingo. Hell yeah. Hell yeah. Good for you. How much stuff did you get packed? Well, enough, but yeah. Don't think for a second I didn't hear you throw Chad under the bus. Well, you guys are pieces of crap, so I don't know what to tell you. Have you discussed Astra yet? No, haven't even gotten to that. Especially you. Not you, or you so much, but you. You. You know who you are. Was it the Astro bit? Yeah, no, Loopy. That, you know what? That's a good point. That's a good point. You guys didn't get... Loopy, that's good, man. I like that. You didn't... You didn't get thrown under the bus. You got thrown under this. You got thrown under the toaster oven with wheels. It's a goddamn toaster oven. Oh my god. Why? What are you doing? It's a toaster oven. Dude, I have that toaster. Dude, we packed up our toaster, but I have the toaster that looks like this. I am straight up going to paint my toaster to look like that. Yeah, I don't know, Loopy. It's Yuppie VW Samba knockoff. It's a toaster. Can you show them leaving for the pad? It's a toaster. Yeah, it's a toaster. I don't understand. I don't understand. You got the pad link for you. Oh, okay, thank you. Yeah, here, let's take a look. We'll get back more into Starship stuff in a second here. I mean, they're cool. I see what they're trying to do here. I'm just not... Why not, like, use a Rivian or something? Like, or a Cybertruck, or the Hoonigan Airstream. You know, like, why... You know what I was just thinking? It could be Starliner's transporter. I'll tell you, contract diversification. Yeah, no, I get that. I don't know, Loopy. They did something. Now, oh, thank you, Eagles. Appreciate it. Now, here. Now, okay. All right. I'm gonna ask, would you guys rather the rolling toaster or this? That's Starliner's transport truck. That's what people are gonna roll to the pad with Starliner. It's just a transit van. Yeah, okay, cool. Me too. I'd take the toaster over that. I would absolutely take the toaster over that. Yeah. Can I get an electric Samba? Yeah. The toaster has more windows. What about the Hoonigan proposal? I wonder why that one didn't go through. I think somebody at NASA probably thought that was too much of the same. You know what I mean? Like we already used an Airstream van. Why would we use another one? You know? Oh, that's cool, Luffy. Right on. Yeah, Loopy. Oh, I know. But Hoonigan's proposal was for one vehicle. Canoe was for like 3 or 4, if I'm remembering that right. So, yeah, I don't know. Now, see, I asked this last time. Okay, so SpaceX is using Model X's. They're using Teslas, all right? Boeing is using a transit van. The shuttle used the Astro van, which is an Airstream 310 RV that's been converted to move astronauts around. The original Apollo astronaut transport vehicle was it was an RV that they converted. So my question is, what would you guys have them move in? Yeah, Synerd, I agree. Segways, golf carts, Harleys, nice. A modern RV, M1 Abrams. Curtis, I like you. I would choose the EV Humvee. That's a good choice, Gold Falcon. Yeah, that's a good choice. A yellow school bus, nice, Panda Man, nice. I mean, they had the shuttle Airstream. They can drive it right out of the Atlantis building through one of the service exits and put that right back to work. Yeah, Loopy, I'm kind of with you on that one. I think it's hilarious how NASA's like, oh, we don't have enough money, but also at the same time. V10 Miata. SBR, I also like you. Corvette, just bring it back. Some C8s, Balxy? Hell yeah. Reliant Robin, nice. Didn't they try that once? It's on loan to the visitor center so they could recall it into service anytime. The placard on the front even says so. The toaster ovens are electric, Drummer, yeah. So, alright. I mean, I actually, out of all the options that I saw, I thought the electric Humvee would be cool. That would be cool. The electric Humvee would be a really cool idea, but we gotta go with the toaster. A10s. That, alright. Sinclair C5s. Jeez. Only $150,000 contract for Canoe to build those 3 EVs. So that's not too bad of an expense. Yes. Yeah. They're just toasters. That's all. I know what a C5 is, Tessa. A jet-powered semi-truck. Tesla Semi outfitted with a bar in the trailer. Dude, I'd like to do a lot of things before I fly into space, John, but one of them that I would not do is get drunk. Can you imagine being drunk in space? That would be horrible. I don't want anything to do with that. No, I'm good. Yeah. Yeah, I'm good with that. We don't need to do that. That would be terrible. That would be I'm getting sick thinking about it. Talk about the worst place to get the spins. Yeah, Sleepy, you'll get the spins, but you'll actually be spinning while you have the spins. That would be horrible. No, I'm good. I'm good. I'm good. We don't need to do that. Anyway. So, yeah, that's what's going on there. While we're on the subject of SLS, let's go see what else is going on here. While teams continue to prepare for Artemis 1 for the next wet dress rehearsal, progress is continuing on future NASA Artemis missions with astronauts. Check out the latest update for Artemis 2 and 3 here. Hey, there's the Artemis 2 engine section. There's the Artemis 2 Orion capsule. There's Artemis 3 SRBs. Very nice. Very nice. Let's see what the press statement is saying. The Orion spacecraft for Artemis 2 was powered on for the first time. Yep, okay, we got that one. Michoud, teams have assembled most of the Space Launch System's Artemis 2 core and moved the final piece. I think that's the same picture. Yep, we covered that. Of the stage in position to complete the stage later this year. The engine section is one of the most complex parts of the core stage and contains the main propulsion system that connect the stage to the 4 RS-25 engines. Very nice. Very nice. The engines have been assembled and are ready for integration with the rest of the stage, while the 10 Artemis 2 solid rocket booster motor segments are stored and ready to be shipped to KSC when the rest of the booster assembly is underway. The interim cryogenic propulsion stage has already been delivered to Florida and is finishing final processing. Cool. More SLS stuff coming together. Now, I have a question. Novus, if you're here, you linked these pictures. I'm not exactly 100% sure what I'm looking at here. I'm going to go ahead and guess that it's Orion parts for Artemis 4. Or Artemis... No, what does this say up here? Michoud Assembly Facility, Orion, Artemis 3, T to FB. That's the welding jig for the Artemis 3 Orion. Oh, very nice. Oh, they're stir welding it. Look at the stir welder. Yeah, there we go. That's a stir welder right there. Cool. Very, very, very good. That's pretty neat. Well, that's pretty neat. Yeah. That's the start of the pressure vessel right there, I'm pretty sure. How does that work? How does stir welding work? Well, you take two pieces of metal and you butt them up against each other like this, like two sheets of a spacecraft. And then you have a piece that pushes down, and on the end of that piece that pushes down, there's a rod. That's the rod right there, and it spins. It spins right on the seam. That generates so much friction that it actually heats up the metal to the point of melting, and it stirs the metal together. Friction stir welding. It takes the metal and mixes it together at the seam. Essentially, what this does is it makes you can take two pieces of aluminum, weld them together, and make it literally at a molecular level one piece of aluminum. Friction stir welding is how most aluminum-based rockets are put together. The reason why is because you have a very uniform molecular structure that's really good in the application of pressure vessels. So something that's pressurized like a fuel tank or a crew capsule, right? Yeah, it's literally doing this to the metal right here. Friction stir welding, only it's going in a circle like that. It creates so much heat that it melts the metal together. But you know, one could make the argument that if you just take two pieces of aluminum and you TIG weld them together, that's one piece. Well, no, not at a molecular level, because the filler rod that you use to weld those two things together is a different molecular structure than the two plates of metal. Stir welding basically makes a uniform structure at the seam. It's a uniform weld, which means that the molecular structure of this here, and here are all exactly the same. It basically mixes them together and makes it one piece, literally. That is such a huge advancement. It's an advancement that, believe it or not, came about in the 80s. It came about in the 80s, and the shuttle's LWT, lightweight tank design, was the first friction stir welded vehicle. They saved a couple thousand pounds of weld in that tank design by literally making the same thing but stir welding it together instead of actually welding it together. Josh, 65 months, thank you. Do you know in particular how a simple match works? It blew my mind. I mean, yeah, so you make it the sparks. They light up at the match. But anyway, yeah, that's a stir welder for Orion's pressure vessel right there. Last. You make it the spark. There's a core stage volume for A3 in the background in the image of the welding jig. Ah, yes. Intertank, huh? He's no spark. It's auto combustion. Oh, cool. That's neat. That's pretty neat. Yeah, that's also neat too. Sweet. So that's pretty cool. So we got the next bit here. Where's the press release? Did I get the press release? I don't think I got the press release. It's okay. So T0 Systems is a guy that works for Sierra Space here. Looks like we're getting a spacecraft crew office. Sierra Space is the company that runs Dream Chaser. And then Sierra Space released this. Sierra Space to open up Human Space Flight Center. Train future astronaut corps for new commercial space economy. I loved your cameo on the KSP podcast. The KS podcast. Yeah, nice. Thanks, Meatloaf. I'm glad you liked it. Hopefully I didn't bore too many people to death. Sierra Space's Human Space Flight Center and Astronaut Training Academy at NASA's Kennedy Space Center will be led by Janet Kavandi, Sierra Space president and veteran of 3 space shuttle missions. Yep. Sierra Space, a leading commercial space company at the forefront of creating and building the future of space transportation and infrastructure for low Earth orbit. Okay. You can have more than one. Announced today that it is creating the world's first fully integrated commercial human spaceflight center and astronaut training academy. Dr. Janet Kavandi, a space industry leader and veteran NASA astronaut, will lead Sierra Space's Human Spaceflight Center and Astronaut Training Academy from the company's offices at Kennedy Space Center. Cool. Nice. Yeah, Sanchai, it's been done. Yeah, they released it. Yeah, no, Jan's done some stuff in space. Yep. Sierra Space is building the world's first commercial space platform, enabling a vibrant new space economy where companies in multiple industries can develop their next breakthrough products and services in the unique environment of space, delivering the discoveries of tomorrow to benefit life on Earth. Yeah. Yeah, Magellan, right? It's interesting that it's at Kennedy Space Center and not at Johnson Space Center, huh? Johnson Space Center is where NASA trains astronauts. Cool. Dr. Cavendi is envisioning 3 categories of personnel in the Sierra Space Human Spaceflight Center and Astronaut Training Academy for evaluation and training. Professional career astronauts who will spend months in space operating and maintaining the first commercial space station, Orbital Reef. The Academy will train them with a skill set similar to those of NASA's career astronauts. Sierra Space team members will be among those entering into this training. Specialist astronauts who are professional customers in other fields will be trained on how to conduct scientific research, manufacturing, and other commercial activities on Orbital Reef. And then experiential astronauts, okay, who want to visit Orbital Reef to experience what it's like to live and work in space. This category will require less intensive technical training with a primary focus on ensuring safe operations. These participants, like all astronauts, will require in-depth physical exams and extensive safety training. Cool. Similar to NASA's astronaut selection process, Sierra Space's Human Spaceflight Center and Astronaut Training Academy aims to commence the professional astronaut selection process in late 2023, with training for the first cadre of selected astronauts to begin in 2024. The company would be able to start flying astronauts by 2026 to begin construction of Orbital Reef. Interesting. They have the shuttle landing facility building to help with training, so they are using existing facilities. Is that where this building is going to end up, Sumo? I mean, that would make sense considering Dream Chaser runway. That makes sense to me. I don't know. Just guessing. I was wondering where. We'll probably should read more. I'm wondering. So they're on Kennedy Space Center. They say specifically that they're at KSC. Well, that leaves a certain amount of places that they could be in. Basically, right here. Anywhere from here to there. Their offices could be anywhere in that box, except, I mean, probably not out here. They probably wouldn't be right there, but you get the idea. Russia has in this program? I don't know. I don't think so. Yeah, we haven't been doing many things in the way of new projects with Russia lately. I mean, pretty sure we all know why, so we don't even need to talk about it. Cool. So, I'm wondering, that NASA is expanding the facilities at the SLF. See that road right there? They are expanding the facilities. And they're going to go all the way down here, and they're going to build a bunch of buildings here. This place is going to look like an airport when it's done, not just a runway out in the middle of the jungle. And Florida is the jungle. It's more swamp than anything, but you get the idea. KSC is the wildlife refuge, Jim. This is all wildlife refuge. They're most likely going to be down here somewhere or right there. But here, let's keep reading. Let's see. Similar to NASA's astronaut selection process, Sierra Space's Human Spaceflight Center and Astronaut Training. Okay, all right, we just got that. All right. In November 2021, Sierra Space secured $1.4 billion in capital, the largest Series A capital raise in 2021, and the industry's second largest private capital raise in history. The Series A investment was led by General Atlantic, Couture and More Strategic Ventures, with participation from funds and accounts managed by BlackRock Private Equity Partners and AE Industrial Partners. The funding is accelerating the development of the company's space transportation systems led by the Dream Chaser spaceplane. In-space destinations for low Earth orbit commercialization, including orbital reef and advancing technologies and space applications. Yeah, they didn't say exactly where they're going to make it unless I scrolled over it. It's interesting that it's going to be, like I said, it's going to be at KSC. That's really interesting. I'm just blazing through this real quick. A crew variant of the Dream Chaser spaceplane is currently in development and will be operational in 2026, having successfully completed its system requirements review. Okay, it did SRR. Cool. Let me get my book real quick. I forget where the SRR is in the process. I have to go book for a second. The SRR is before CDR, if I'm remembering right. Okay, so they have an MCR, mission concept review, and then the system requirements review, which is where we're at right now. And then there's the system definition review. Then there's the preliminary design review, critical design review. After the CDR, that's when you start making things. This is all drawing in theory up until the CDR. Well, not theory, it's drawing. Up until the CDR. Then there's the system integration review, operational readiness review, and then you're flying. Cool. So they're at step like 2 out of like 2 million. It's going to take a little bit. Orbital reef will be on orbit and operational in 2027. NASA awarded a commercial LEO destination contract to Sierra Space and Blue Origin in 2021. Cool. All right, well, that's actually pretty cool news, guys. We got Crew Dream Chaser. Crew Dream Chaser is on the books. That's really freaking cool. You know why that's really freaking cool? Because it gives me an excuse to show my favorite picture of Dream Chaser. Where is it? Where is it? Where is it? We'll find it. We'll find it. We'll find it. It's okay, chat. It's okay. Relax. Chat, go relax. I think NASA wants to get some revenue from shuttle era facilities at KSC. Other aircraft sometimes use the SLF for operations, but building it like an airfield will help with the utilization of facilities. You know, they could do that whole thing, Neuro. There's this thing that they could do called flying the space shuttle, and that might get them some Oh, wait, no, we can't do that. It's too old. There's a reason I like this picture. First and foremost, spaceship. Second and second most, Ferd. Third and third most, fuzzy dice. Yeah, fuzzy dice. I like the fuzzy dice. Hopefully this picture becomes reality with a craft that just came back from space. Are the shuttle era engineers still around? If they decided to reboot, they'd be able to help. Yeah, but they all have other jobs, Rares. They've like putting a band back together like that would be very, 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 very hard to do. Everybody got jobs in the private sector or they retired, you know? Yep, they're AOs. Since Dream Chaser actually has wings, does it fly better than a brick? It doesn't have wings. It has stabilizers. Those are V-stabs. Well, V-stabs and H-stabs. This is the wing. The craft is the wing. It's a lifting body. Now, does it fly better? I mean, here, Dream Tracer drop test. Here. Yeah, Neuro, that would have been the smart thing to do.
We see lift.
Jeb and Val are on Artemis. That's cool.
We see a good lift. Nice job, 9 Charlie Hotel.
You tell me how it flies.
Minos go.
Release, release, release.
Steep dive.
Good flight controls. Copy, good flight controls.
I'd say the shuttle flies better than that. Man, that thing falls like a brick, dude.
Radar altimeters.
Approach and land. PTIs.
Copy, approach and land. PTIs are active.
End of PTIs.
Copy, PTI is complete.
No, come back. Boop. Come here. Come here.
400 feet.
Copy, 400. Landing gear commence. Copy, gear deploy. Good gear deploy.
I mean, not bad considering it did that automatically.
Touchdown.
What rocket can take that into orbit?
How are the brakes?
One that has rocket engines on it? I don't know, Lunchbox. I don't know the carrier vehicle. I'm going to guess Vulcan. But Vulcan is for uncrewed Dream Chaser. That's different. So I'm not sure. Yeah, here, you want to see something? You want to see something a little strange? Watch the left landing gear. Watch the left landing gear. Right after the nose touches, right? There. Watch. Okay. Hang on a second. Got some F-16s back there. More F-16s. All F-16s up in there. Ooh, F-5. Cool. It's just brake pressure, guys. The brakes, they have to adjust the proportioning valve on the brakes. Is that supposed to happen in Kerbal when they touch down on the runway? Is that supposed to happen in Kerbal when they touch down on the runway? I don't know. What? Yes. Anyway, next news. So Astra launched the Tropics 1 mission on Sunday, and here, let me get to the let's get to the good stuff. So This was out of Complex 46 here at Cape Canaveral. NASA Spaceflight did do the cast here, so let's just go.
4.
Pretty good.
Chamber pressure is nominal.
Our next objective is max Q, which is the period of maximum dynamic pressure on the first stage structure during flight, which is coming up just after 1 minute.
So let's just.
Aerodynamic below.
The wind is taking that little thing, huh?
By launch, we will.
So this is a mission for NASA. This is the Tropics 1, which is a, I think it's a, an oceanographic survey satellite, if I'm remembering correctly.
2.5 minutes in the flight, again coming up on main engine cutoff and just about the payload fairing separation. This is a camera on the upper stage. And there's stage separation and ether ignition, upper stage ignition. Now the upper stage will burn for just about 5 minutes on its way to low Earth orbit. Again, everything looking good so far.
So everything was looking good up until this point.
You can actually see from the onboard telemetry the vehicle is actually already in space. However, it has to get that horizontal velocity needed to stay in space via achieving low Earth orbit. So we're going to be watching that velocity marker tick up on the bottom right of your screen. 3 minutes after that.
Deployment.
Again, the target course,
No, we, oh.
over a minute left.
We cashed out our Astra shares. We needed to cash out all of the stocks. All the Stonkmo stocks, Foz, we cashed them all out for a down payment. So we wouldn't go into the poorhouse when we bought the house. So yeah, no, I don't have any shares in Astra or anybody. We cashed out everything. We'll reinvest some other time. Made money for what it's worth.
Left and the planned upper stage burn.
Oh, crap. So we're, yeah, 6,500 meters a second, not close. When the market finds the bottom. Yeah, exactly. So, yeah, something happened with the second stage here, which sucks. I mean, that sucks. You wouldn't want to wish anybody failure here, but they Astra did lose the Tropics 1 mission, which does suck. Something went weird with that second stage again. I don't know what it was this time. From what I can tell, it looks like it outgassed the motor. So that tells me that the computer shut it down. When you see a big puff come out of the engine like that, that looks like a scheduled shutdown, like the computer commanded the engine to shut off. But I don't know. The payload, which, like I said, I think it's an oceanographic satellite, is, I'm going to hell for making this joke, is at the bottom of the ocean. That sucks. Like the stock price. Yeah, it's not fun. You don't wish failure on anybody that's crazy enough to actually go and do this. So apparently they're running out of cash. They have 275 million in cash, but last quarter had a loss of 85 million. Oh man. Yeah, they really got to figure that stuff out. Guys, I don't know. Like, I think it's important to say that I don't have any affiliation with Astra. I don't have their stocks. I had to cash out because down payment on house. But also, you know, I don't, you know, I think it's important to know that I don't know better. But what I'm seeing here is, with this pattern of failures, is that it's something different every time. Now, why would it be something different every time? Well, does that mean that the company has a QA issue from the ground up? No, I don't think so. I don't think so because they have had successful missions. What I do think is what's going on here is that they're not baselining the rocket. And you guys tell me if I'm wrong. Once again, I don't know any better. This is just my idiot armchair rocket scientist analogy, or not analogy, that like kind of analysis. Sorry. I think because something different is going wrong, like I've never seen that behavior before. We've never seen the engine commanded off at 6,500 meters a second, which is like 9/10 of the weight. Well, not 9/10. It's like, I don't know, it's a little bit over 3/4 of the way to orbit. That's pretty dang close, but I've never seen that behavior before. I mean, there's obviously the rocket that went sideways. There's the second stage mixture problems. There's rockets that have worked. So, and I was thinking about this, and I noticed that Astra upgrades their rocket. They change something every time. Now, generally, that's not a good idea. I'm not familiar with how Astra works. I'm not familiar with their intricacies to engineering, like how they go about doing it. That might be how they do things. But what I've noticed is that they haven't really baselined a rocket. Every single time the rocket is different. It's rocket 3.1, then it was 3.2, then it's 3.3, right? Now it's 3.4. Like, everything is different. At some point, you're going to have to baseline something for a minimum viable product, because you can't. I mean, Rocket 3.0 has like a 20% success rate or something at this point. That's really glaringly bad. 2 out of 7. Ugh. Yeah, Gabe. Yeah, right. Got to give it to them. Their failures are interesting. I don't recall seeing a second stage fly through the fairings before like they did. Yeah, it blew its way out of the fairings. Yep. How much changes between rockets? Well, enough to change the version number on its supercraft. So, like I said, I'm just an armchair rocket scientist. I don't know. I play Kerbal. But I know that changing things in Kerbal like that does open you up for more risk. And if the company... But on the other hand, Astra that's the whole point. They're pioneering a less risk-adverse style because their rocket is very inexpensive and easy to manufacture comparatively to other rockets because it's made with basically basic tools. That's the cool thing about Astra. Their rockets are made with stuff that you could go buy at the hardware store, with the exception of the engines. I mean, the engines, obviously, you can't buy those at the hardware store, but... I honestly, no, Hellfish, no. I'm not gonna say that they're incompetent or anything, because that's most likely not what's going on. Incompetent people don't do this. They don't do stuff like this, because incompetent people wouldn't have the balls to do something like this. Let me put it to you like that. I'm not saying that Astra is bad. I respect anyone that's ballsy enough to throw their hat into the ring here. I think they keep changing things, and I think that them changing things is screwing them up. Because we've seen a bunch of different failures, and every single time it's been a different failure. So, if I could pick one thing and bet on if that's the problem, I would bet that that's the problem. But I don't know for sure. And once again, I want to be very clear. This is more opinion from me. I don't have anything against Astra. This stuff is difficult, man. It's tough. It's really, really complicated. A bajillion freaking things can go wrong. It's so difficult. They're like, guys, we've been spoiled by SpaceX. They make it look so easy. It's not easy, man. It's not easy.
Discovery, go at throttle up.
I would say stick to the design that works down the road. Well, that's what I mean, T-Man. They had a design that worked, and then they changed it. Then we upgraded it. It's Rocket 3.3 now. It's like, okay. Why would NASA pick them for launches when their track record is so bad? I don't know. Hey, J-Shelf, 25-month resub. Thank you. Oh, cool, Ryan. All right, sweet. If you don't know what they're changing or how they're changing, how can we assume that the changes are at fault? Livid, it's a guess. Yeah, it's a guess, and I want to make that very freaking clear. It's a guess. I'm just guessing. That's just kind of my opinion was what's going on. They keep changing. Like, what else could go wrong? I refuse to believe that the people working on this are stupid. They're not. They're not stupid. Those guys know what they're doing. I know they know what they're doing because they've gotten stuff into space. You don't get something into space and not know what you're doing. You know? Yeah, caveman, if it ain't broke, don't fix it. You really got to do that with rockets, you know? You got to get yourself into a routine and then start changing things. But I don't know. I just hope, I wish them the best, and I hope that they get back on their feet. This is hard to do, and like, if it's one thing that I'm learning, and this is with my knowledge of like our mission mode adaptive rules for like Kerbal. When you're down in this industry, you are down. You will get kicked in the teeth when you're on the ground. And this one was a kick in the teeth to Astra. I guarantee you that it hurts, man. It hurts seeing your stuff blow up. Simpler manufacturing processes have poorer quality, which results in more performance variability than one might think. Astra's rocket doesn't seem to have much room for any error, but it is made with many. Yeah. I mean, that's one of the reasons why I think Robert Truex was a freaking genius. Because he knew that if you're gonna manufacture a rocket with off-the-shelf stuff, it's got to be overkill. That's the only way you're going to compensate. I would expect to see a similar track record with early Starship for reaching orbit. Yeah, probably. However, they seem to be in the trap of perfect being the enemy of good, which shows someone is making mistakes. I think it's changing the rocket all the time, Hellfish. I think the rapid upgrade prototype stuff. You gotta, like, I don't know if you should freeze the design, because, like, on one hand, the space shuttle, they froze the design after Challenger, and then they made it safe. They weren't focused on making it reliable. They were focused on making it safe. You know, maybe Astra should just keep running the course. They'll get it eventually. Just how much runway do they have? Falcon 9 1.0 only flew 5 times. Yeah, but none of them failed. Supercraft. Does that make sense? One had a partial failure with a Merlin 1D shutting down, but I could tell when they ended the cast. I don't even want to watch it, Hookie. Like, I don't. Watching that for me is like watching someone get kicked in the nuts. It's like, you know it's going to happen. You know there's going to be pain. I don't need to see that. I don't need to see that. I thought, sorry, Falcon 9, not Falcon 1. Huh? Yeah, mm-hmm. I see one problem. They appear to me to be making changes on the fly and experimenting with payloads. That's a bad yeah, I mean, I don't know. Maybe that's what they're trying to do. Either way, I hope that they get on their feet. This is hard stuff, man. It's difficult to do. It's a difficult task in general, and then it's difficult having a bunch of people work on said task, you know? Like, that's tough. That's tough to organize, and it's tough to do right. Falcon 1 was 1 for 4. And see, you guys are saying, oh, well, SpaceX had failures. SpaceX had failures and they upgraded. You guys understand that Elon Musk himself said they had a very low probability of success. Like, they barely got past where Astra's trying to get past right now. Like, that's by Elon's own self-admittance. He's like, no, we were like that close. We were that close to going belly up. Also, Elon Musk bailed out SpaceX with Falcon 1. What? No, he didn't. He founded the company. That's what are you talking about? Bailed out SpaceX with Falcon 1. No. NASA bailed out SpaceX. NASA's, you know what program, believe it or not, you know what program bailed out SpaceX and got them the contract for commercial orbital transport services for Falcon 9? The contract that basically willed Falcon 9 into existence? Constellation program. Yeah. Commercial orbital transport services was a part of the vision for space exploration. Yep. Constellation. Yep. Astra is also a very young company without very many industry veterans. They got a lot of things they don't know. Yeah, yeah, that's right. Yep. I thought that he used his personal funds because they couldn't do another launch after the failure. No, he used his personal funds to make the company buy those. Yeah. Have you mentioned your upcoming adventures to chat today? I was waiting until the end of Space News, Primo, when the most amount of people are here. He talked about how he put lots of money into the launch that finally worked. If they had failed, that would have been over. Is there a common development cadence for the life cycle of a rocket? Per NASA standards are, but all these commercial companies, there's really no standardization in the industry. Rarest, from what I understand. Everybody does their own testing. Everybody has their different engineering figures. It's very much the Wild West for rocketry right now, which is not a bad thing. That's really cool. If Astra is where SpaceX was, does that mean that there's a blueprint they will follow to develop new launch vehicles? Nah. Different circumstances, dude. Important question. Do you have an adventure hat? I need to let Manev know. An adventure hat? What does that mean? I missed it. I asked earlier, but he was in the thick of Satisfactory. What do you want to know, Magellan? Hey, Predominant. How are you? You don't have a shirt like this in real life? Your field trip thing. Oh. I mean, if you guys want to talk about it here, that's fine. So, guys, the stream will be irregular schedule from the 21st to the 25th next week. The reason why is because, well, Das and I are attempting to bring the virtual field trip back. Spaceport America Cup, baby. We're going to go, we're flying out to New Mexico next week, and we're going to cover the Spaceport America Cup for NASA Spaceflight, and we can stream it here on the stream as well. So, yeah, next week, yeah, it's going to be a little bit of an irregular schedule for me. You're not going to see many games being played, but you will see actual model rockets, high-powered rockets being launched. What's the Spaceport America Cup? Long story short, it's a bunch of colleges coming together to compete to see who can launch their rocket the highest. It's pretty freaking cool. We're not seeing orbital rockets, but they're pretty damn big. They're about as big as you can get for rockets before you move to something like Astra's or Electron or Minotaur, you know? Are you going to be roaring at many of them? I don't know, maybe. Yeah, they're cool. They're cool rockets. Yep. NASA Spaceflight is a proud sponsor of the 2022 Spaceport Cup, brought to you by Sierra Space. Thank you for your support and combination. Combination. Okay. So yep, that's what we're doing. Das and I, we're getting the band back together. Speaking of launches and cool things, we have 3 back-to-back launches for Falcon 9. Yep.
Listen, Tranquility Base here. The Eagle has landed.
Whoa. Okay. Okay, that VFT. Yep. Jeez, that was $150, man. Thank you very much. You at a model rocket event. Who are you? What? This is not a model rocket. This is high-powered rocketry, Hellfish. But this is a good opportunity to get VFTs back on the table, dude. Yeah. Das and I had a crazy amount of stuff planned at the beginning of 2020. And some of it was, yeah, I don't think I should talk about it, but yeah, we're trying to get that back going because for some reason, you know, we haven't been able to do virtual field trips over the last couple of months or years. It's months in my mind. You know what I mean. Yep. So, yeah, 21st through the 25th, we're going out to the desert. If chat wants to learn more, Spaceport America Cup. Thank you, Hell Hydra. Yep. Yeah, high-powered rock. Yeah, Hellfish, it seems lame. Trust me, it's not lame. It's cool. It's pretty rad. I sorely missed the VSTs. The last one was Seattle, I think. Yep, the Museum of Flight. That's the last one that we did. Baxi, we had, oh, guys, I can't talk to you about it. We had, like, I don't want to talk to you about it because I don't want to, like, maybe this stuff is good, maybe it's not, I don't know. We had some gnarly stuff planned. It's just a shame. We had some, dude, I'm like, even I myself had some crazy projects, crazy side projects. It'll blow your freaking mind going at the end of 2019. Oh, there's so much stuff that fell through because of COVID. It sucks so hard. But we're trying to get that. We're trying to get that going again. Putting the band back together. Occasionally, semi-amateur rocket folks will get missile motor surplus. Yeah. So yeah, I'm glad you guys are hype on it. Yep. So if these rockets have proper instrument packages on them, would they qualify as sounding rockets? Something like that. Okie gifted us up to Hell Hydra, and thank you for the tips, guys. And oh, wait. Did Das come in and resub and say, it is true? We're putting the band back together. We're on a mission from God. What's up, man? I was just telling these nerds in here what the plan is for next week. I think you guys will appreciate it. The band back together confirmed. Yep. I was actually just telling them, we were just talking about all the plans that we had for 2020, but that didn't happen. But hey, it is what it is. You're gonna need new suits. Yep, so that's what we're doing. And hopefully this is a primer to get back to doing bigger and better things. Because we had some cool stuff planned. It was pretty dope. But if you need a less well-known DOS to join the VFT, just let me know. Okay. So, yeah, that's where we're going to be next week, guys. Spaceport America Cup. It's going to be NASA spaceflight coverage, but we have kind of a hybrid thing going where we can stream launches here, we can stream interviews here, to Das and my stream. So you guys don't need to go anywhere next week. It'll still be here. There's just, you know, there's going to be some of it on NASA spaceflight, some of it here. It's going to be sweet, man. It's going to be awesome. Hopefully Kids Weeks comes back. Yeah, that'd be nice. Hey, Racer, what's going on? Yep, will be a small amount of stuff on the official NSF channel and lots of stuff here. Bingo. So it should be a good time. Yep. Can you tell my boss I don't have to go anywhere? No. It's like all behind the scenes stuff here on EJ, yeah, on the Twitch channels. Yep. Yeah, it should be fun, guys. Should be a good time. So yeah, that's what we're doing next week. So there's not going to be much in the way of games being played, but we will have some pretty cool footage for you. These high-powered rockets are cool. Here, you know what, Hell Hydra, I'll show you the link. Take a look. Das has done this before. He's been out there covering it. Here, take a look. You guys want to see the Yeeter Stick 500? Look at this thing.
10, it should be somewhere out there, Chet. 13, be looking now.
14, 15.
There goes the valve.
There's the valve, there it goes.
Yeeter! Whoa! Dude!
There's that big.
Das, you see that? Steaks on me, dude.
Good.
Steaks on me.
Good.
9.
How's that? So trust me, this ain't model rockets, guys. This is like Yeeter 500s going way up into space. Another one if you want. I would love to see this. Oh no, thank you very much, man. So it looks like we got some steaks on. But yeah, trust me, guys. This is, you guys will enjoy this. We wouldn't bring this stuff to you if we didn't think you would like it. Trust me. I mean, I'd like to think at this point, Das and I know what's boring and what isn't. All right, here, let's check this one out.
They're good.
What? Yeah, baby. Oh.
Wow.
Okay. What's the TWR? The TWR is Mach 1. Yeah. In like a second or two. They have 150 plus teams registered and expect 120 to field rockets. Oh, it's gonna be fun, man. It's gonna be fun doing this stuff again. I'm so ready. Oh, I'm so freaking ready. Can I watch this one more time?
They're good.
Yeet! Look at that.
Wow.
Look at that thing go. Man, that's quick. That's so fast. Oh man. Thank you for all the tips, guys. I do appreciate it. Wait, what's going on here? Tipsy, so that was Spaceport America Cup from 2019. Das and I, yes, that Das, he still exists, I swear. He's not a figment of your imagination. Trust me. Next week we're going to cover the Spaceport America Cup. And we're going to stream it. We're going to stream a lot of behind the scenes stuff, a lot of launches here, and some stuff on NASA spaceflight as well. Yeah, we're gonna go out there. We're gonna cover some high-powered rocketry launches. He does exist, same time. Should be good. You just gotta be running a tracking camera. Oh boy. Oh boy. Yep. Yeah, so that's just some clips from what's going on there. Will we see the return of Go Baby Go? God, I don't think I should yell at rockets anymore. I don't think that's a good idea. There are things going fast, and then there are things going, yes. Oh yeah, no, these things get up and go. Neuro already said it in chat. A lot of these high-powered rockets are like on par with like a Sidewinder missile. They're just, bye-bye, you know. Don't mess up with an important job like tracking. Hey, wait a minute. My tracking skills are on point. You ever watch me play a shooting game? Yo, I got the sleight of hand, dude. Look at I got the flick of the wrist. Look at the wrist. Look at the flick of the wrist. Is that still a meme? I don't even know. Whatever. Do they have public telemetry? Oh, I'm not sure. Yeah, so next week is gonna be some pretty awesome stuff. Yeah, those are old pictures. I remember when those pictures were posted, Creeper. 2016 called. They want their meme back. Your mom called. She wants me back. Got him good. Anyway, so yeah, that's what we're doing, guys. 21st to the 25th next week. Yeah, so non-regular streams, but we get to see some really, really cool high-powered rocketry. EJ's tracking skills are like, why do you keep doing that? Stop bringing that up. Stop it. You stop this now. Anyway, Das, thanks for dropping in and helping me drop some additional information. I thought you guys would appreciate it. Why you gotta keep kicking me when I'm down, man? It's ridiculous. Anyway, let's see what else we got going on in the space world. I think the next thing is rocketlaunch.live here. We're gonna look at our upcoming mission. So let's see. 17th, 18th, 19th. Damn. We got Starlink 419 on the 17th, which is on Friday at 10:50 a.m. That's the 13th flight for 1060 here. That should be really, really good. And then on the 18th, we have another Falcon 9 that literally the next... Oh, Jesus. Okay. Oh, boy. Oh, frick. Yeah, okay. That's gonna be... That's gonna be not fun. Lovely. That... Okay, that kind of sucks. And then there's another Falcon 9 at 12:30. Yep. That's, yeah, we're gonna have to cover that. So I'm probably gonna stream all during the day and then go, and then we'll come back for that one there. And then I thought that said meat slab for a second. Jeez. And then after that, that's into the next week. So Daz and I are gonna be down there on the 21st through the 25th. So Tuesday, Wednesday, Thursday, Friday, Saturday. I'm not sure if I'm going to end up streaming on Monday, fellas, but yeah, should be good. Yeah, of course, Gabe. Yeah, of course. But also, why you got to keep bringing that up, man? Damn, meat sat. Yeah, right? Meat sat. Anyway, let's see what's going on with the footage from Boca Chica here, guys. I think that's the last thing for the day. Let's, Ooh. Relativity just posted this video. Here, let's take a look. What did they post here? What do we got? So this is coming from Relativity. Let's see. Okay. Oh. Hey. Wow. All right. Pottery, but with rockets. That's pretty neat. Can I order, please? Just... Jeez. What if we made a rocket just out of welding bead? That's literally what that is, dude. That's... It's just a freaking MIG welder that's just on a spinning turntable. I mean, I know it's a little bit more complicated than that, but also, jeez. I mean, look at that. They're just printing the bulkhead straight up. That's nuts, man. Actually, Das, Relativity's getting ready to go. Why am I telling you? I'm sure you know already. Yeah, they got their first and second stage pretty much good to go. They're going to launch. I think they're launching at the end of this year, right? Something like that, end of the year. They're, yeah. 3D printed rockets. How did we get here? When did this happen? Like, all right. Link to the video? Sure, that's coming right from Relativity's YouTube channel. The future is now, old man! What do you know about Minor Planet 26654? I don't know nothing. I know nothing. I know nothing. I don't know what this is. What am I looking at? Do you think this kind of part requires a lot of machining afterwards? I don't think so. No. I mean, they probably surfaced it a little bit somewhere. But no, I don't think so. Which is pretty rad. I mean, Relativity, what they're trying to do is come up with a rocket that's mostly 3D printed. The hardware and stuff, like the nuts and bolts that put it together, aren't 3D printed, but like all the primary flight structures and primary structural components of like the engine and the tanks are all 3D printed, which is pretty gnarly. And they have a working qualified first stage sitting in their HIF at Complex 16 down at the Cape. It's unbelievable. It's called Eric Johnson. Oh. Word. Nice. It would require some final machining, but 90% would be, yeah, I mean, yeah, you're going to get byproducts from the manufacturing process, but yeah, it's pretty crazy. Nice, Steinert. It's probably not named after me. There's a lot of EJs out there. Anyway, so let's go see what's going on with Mary, Nick, and the NSF robots down in Boca Chica. I think where we last left off, let's see. Where were we? The E-dome rolled back, chopsticks used ahead of testing. All right, here we are. So this footage was shot by Mary, Nick, and the NSF robots. You guys know our buddies over at NASA Space Flight. Go over there, give them a sub if you can. Supporting them over there supports me over here, and it allows me to put my terrible commentary over these videos. You know the drill. If you're not subbed over there, go do it. I don't know if you want to hit the bell, do it. I don't know. They post videos daily. We get to see what's going on with SpaceX. It's pretty freaking cool. Just saying. It's pretty freaking cool. So this is from a couple of days ago here. We're a little bit behind because it was over the weekend. So let's see what we got. Yeah, that's right, Tessa. NSF has the McGregor cam now where they have eyes on the testing facilities. Seen a couple of Raptors blown up in the past couple of weeks, but that's what happens when you're pushing the envelope of space. Stuff's gonna blow up. It happens. Let's see what we got. Second try, did you cover this yet? They know what caused the hydrazine leak on the CRS mission. I have not. The CRS-25 cargo drag into the ISS is now net July 11th after SpaceX was able to narrow down the source of the issue to a Draco thruster valve inlet joint. After offloading propellant from that region, SpaceX was able to narrow down the source of the issue to a Draco thruster valve inlet joint. Team will now remove the specific hardware to replace it ahead of the flight. NASA and SpaceX are now targeting net July 11th for the CRS-25 cargo mission. Okay. Cool. We can talk more about that after we review the footage if you want. I think SpaceX removed the part and replaced it, but I think it's really important that they're going to need to go look at that thruster inlet joint and figure out why it did what it did. That's the really important part. You know, troubleshooting anything mechanical isn't just replace the part, especially when it comes to rocket science and rocket engineering. You don't just replace the part and just say, nah, it's fine. It works now. You want to really figure out why. It sounds so strange to say this like this, but with rocket science, guys, it really comes down to understanding what the heck you made. You got to understand what you made. You don't understand what you made, well, then it's going to do something that you don't get, you don't understand, and that, with rocket science, doing something that you don't understand usually means failure. Usually. It means failure. Bad failure. Like I said, multiple explosive direction failure. That's not good. But I mean, you know that NASA's got it under a magnifying glass, figuratively and literally. The SpaceX and NASA will figure out what went wrong. But it's important to understand that behavior. That is the most important part. Have we seen the toasters on wheels yet? Yes, we've seen the toasters on wheels. real quick. Das, are you still here? Have you seen the toasters? The toaster ovens yet? Is that cool or not? I can't tell. It's kind of cool, but also it's a toaster. I will say this looks real sharp in panel van format. I do like that. That's cool. But also toaster oven. Which way's the front? It's symmetrical, damn it! Which way is the front? They look like hamster. Oh my god. I like the panel van one. That's actually kind of cool. I don't have a problem with that. But also, the white one isn't too bad. The other ones, yeah. What? Das, you know what this reminds me of? Here. You ever see those old, like, you know, those old projects that people work on where they weld the front of two vans together? Two vans welded together. Like, there was a guy around here that drove around in a van that kind of looked like that. James May's limo. I'm sorry. Like, I don't mean to dump on Canoe. I don't mean to dump on them so much, but Jesus, man. Down by the river. It's like I don't know what to say. It's like this, man. Oh my god. I don't. Anyway, toaster ovens. Let's get back to Mary and Nick's footage. Hey, whatever. Alright, let's see what else we got here. You'd like their pickup truck. Their pickup truck? Let me see. Alright, let me see. You know what? I don't mind it. I don't mind this. It's the toaster thing that I can't get over. That's actually really cool. That's cool. I really, really don't mind this. I wouldn't mind this whole thing if they just made the back flat and didn't make the back look literally exactly like the front. I honestly don't have that much of a problem with canoes. They're cool. Like the MPDV, that's cool. But the lifestyle vehicle literally looks like a Fisher-Price toy, man. I'm not going to lie to you. It looks like a Fisher-Price toy. That's cool. That's cool. That's loading. I just make the back flat. Make the back flat. That's cool. I don't mind that. The MPDV is cool. That's neat. I think that's really good. That's a panel van. Great idea. This is a great idea. You will sell these like hotcakes if you sell them at the right price. But what? It's a toaster. Like, just make it flat in the back. It looks exactly the same. Why are we toaster phobic? I don't fear toasters, Tomast. I just don't. It's just weird when a car looks like one. You know why? Because toasters are designed for toasting things. Cars are designed for moving things. Okay? Now, you could move a toaster inside of a car. And on some cars, you could plug the toaster in and toast bread in a toaster in a car. I'm sure someone's done that. But also, I don't need the car to look like a toaster if I'm toasting toast inside of a car with a toaster. Yeah, there you go. That's my final statement. If you were the head of NASA, would you consider replacing the RL-10? With what? You guys smell toast? You guys smell burnt toast? I don't know. Oh, but you stop. You're making my brain hurt. I know, Tessa, I know. Are they raising the tent using shipping containers? Yep. I would say that that's the industry norm at this point. So, yeah, what they're working on over here, that's the Star Factory. That's a permanent building. And eventually they'll take down one tent, move it in here, then they'll expand the building, move the second tent in there, and they'll expand the building again. All told, this building that they're making down at Boca Chica, it should be pretty big. I don't know if it's going to be as big as the one at the Cape, that 300,000 square foot gigantor of a building at Roberts Road, but it's going to be pretty large. We're working on, yeah, that's 24. Now, see, I'm wondering now, because in the programmatic environmental assessment guys, they said that SpaceX is pulling the plant production. Or no, was it the power plant? It was the power plant, wasn't it? It wasn't the propellant plant. I was going to say, like, there's still guys working on this, but then again, this was a couple of days ago. Rick and Morty predicted it. Yeah, I know. Toaster van. Yep. Like a Pop-Tart. It was the desalinization plant and the power plant, Hibbit. Yeah. If you were the head of NASA, were you consider replacing the RL-10 with a J-2 for the EUS upper stage? Any J-2 is fair game. No. I mean, to be fair, it really depends on what you're doing. What are you doing? Where are you trying to go? What are you trying to do? There are many cases where you know that the EUS has more Delta V than Ares 5's upper stage, right? It has more Delta V because RL-10s. It does not have the TWR, but TWR doesn't really mean a lot when SLS with an EUS on top can move like 120 tons into low Earth orbit, plus the stage. TWR means nothing. It just needs to be good enough to get you on translunar injection. So the TWR can be done. Like, that's not a big deal. And then you have to deal with propellant boil off and stuff. But the EUS, if you're doing straight transfer burns, right? The EUS could be used to go to Mars. It could be used to do anything. It has way more Delta V. It's way more of a versatile stage than the Earth departure stage, I think, at least for going to the moon. Now, with that being said, it has more Delta V, but the Earth departure stage was, for Constellation, was really designed and optimized for lunar transfer. So I think, on the other hand, it might be a good idea to have your lunar space program have stages that are optimized for lunar transport. They did that once on the top right monitor up there. Yeah, they optimized it for going to the moon and then figured out other things to do with it later. They didn't just make one stage that could do moon stuff, but also could do other things. So I do like the EUS. The EUS is good enough, and I'm happy that they're going to do it. I can't help but think in the back of my mind that the Earth departure stage might be better for lunar infrastructure in the short term. Not so much for the long term, though, but who knows? Can we almost say that TWR doesn't matter once we're on orbit? It depends on where you're going, Aldesert, yeah. You can have a spacecraft that has 6,000 meters a second in KSP. You can have a spacecraft that has 6,000 meters a second. More than enough Delta V to land on Mun in KSP, for instance. Try to land on the Mun with an ion engine. To be fair, I'm not saying that that's impossible. That is totally possible. But you really got to make sure that you might have all that Delta V, but you ain't going to get it if you have like a 0.5 TWR or like a 0.2 TWR. You're not going to get that. You're still going to be slowing down when the surface shows up. So TWR does matter, but it really depends on what you're doing. There are certain circumstances where it probably wouldn't. Do you have people on board? If you have people on board, you probably want a higher thrust to weight ratio. The reason why you'd want a higher TWR with people on board is because, well, they can't just sit there and be burning for the moon for like 4 or 5 days because there's that life support thing. That's kind of important. So, overclock it, duh. Yeah. That's a long Suez burn. Yep. So, it does and it doesn't matter. It really depends on what you're doing, guys. I mean, I think the EUS is good enough it's good enough to do what the EDS can do, but the EDS was much more specialized for going to the moon. You can use the exploration upper stage for SLS to go anywhere else. You could send probes anywhere. You could send probes to Pluto with that thing. And you could send probes to Pluto for like nothing. It would take like half the time. And, you know, people are going to say, oh, but SLS is price tag, AJ. Well, if SLS means that you could get something to Pluto in like 5 years instead of launching it on a Falcon Heavy and it would take 15 years, because that's the Delta V difference we're talking about here, then instead of having your engineers sit around and do nothing for 15 years, they're only sitting around and doing nothing for 5 until the science yield happens. So in the end, you actually save money. That's my theory with Europa Clipper. Fellas, Europa Clipper was recently put onto Falcon Heavy away from SLS. And the mission promptly quadrupled in time to Europa. Yeah. SLS would have gotten it. I don't know the numbers off the top of my head. I forget. SLS would have gotten it there in like, I don't know, 2 years. Europa Clipper is going to take like 8 on Falcon Heavy. Yeah. Okay. Also, it's really idiotic to change the launch vehicle this far into a mission, this far into the mission's development. Also, the Europa Clipper really didn't get past CDR. It didn't get much of the way past CDR. They were fabricating structures, but also, you don't change the launch vehicle after you fabricate structures, because then you have to undo all the work and start over. So, if I had to guess, and I could be reaching here, and I also could be very wrong. There are people that know way more about this than I do, that get paid to do it. I just get paid to sit here and come up with crazy crackpot theories, right? I think that Europa Clipper is going to end up costing us billions of dollars more, despite the money saved on launching it on Falcon Heavy. I really, really think so. It'd cost $2 billion to the cost. You would add $2 billion launching it on SLS at least, because you have to build an SLS, right? And that is expensive right now. Of course it is. It could be inexpensive in the future. It depends on how many SLSs we want to buy, right? You buy more, the price goes down. Literally, buying in bulk works with rockets. Ask Elon Musk, he knows. Yeah, that works. And it's a double bonus if it's reusable, right? Now, launching on Falcon Heavy, the mission's going to take 4, 5, 6 times as long. And I think the cost will go through the roof. Because once NASA has these things called critical design reviews for a reason. These critical design review is an element of systems engineering, okay? When you have systems engineering, all right, the CDR is basically the point where you start putting things together. You start manufacturing components, okay? The idea is that all the things that lead up to the CDR, which we just went over, it's the SRR and then the PDR and then the CDR. Like, this is all basically, let's figure out what we want to do, draw up all the plans for what we want to do, make the blueprints for everything, figure out how everything goes together, and then once that's good to go, then we start making things. When you change something after CDR, you will inflate the costs of the mission exponentially over time. This is not me making this up. This is right in NASA Systems Engineering Handbook. Literally, you want to figure out what I'm talking about? NASA Systems Engineering Handbook. It's free. You can go download it on the internet for nothing. It's NASA public resource. Cost will balloon exponentially when you change stuff after the CDR. With that being said, SLS has been changed after CDR a bunch of times, which also kind of explains why it is the way that it is. Same with the EUS. Also with Europa Clipper, ironically. So we're going to save money launching it on Falcon Heavy, but the mission is going to take The mission is going to take like 5 times as long to do. And operations, the Systems Engineering Handbook also states that operations can account for half of your cost. Half of your cost. Yeah. At the very least, it depends on the operational life cycle of whatever you implemented, whatever systems engineering construct you implemented. So, operations will basically get up to 50% of the cost. So now you expanded the mission by 5 times. The mission is 5 times as long, and operations are more than 50% of that 5 years. Think about it. Europa Clipper is going to end up like James Webb. It's going to cost us billions of dollars. Yeah. Not necessarily because they switched from SLS to Falcon Heavy, even though that is going to hurt, and that is my main point. They changed things. They're changing things with this mission after they've done CDR. That is a red flag for pissing away money. And also, there's a really important thing here. Less science gets done. Yeah, there's that whole less science getting done. You know, what do you think these engineers that design Europa Clipper, that are on the Europa Clipper, what do you think they're going to do with the satellites coasting out there? They're going to go work on other projects, right? But they're still getting paid for Europa Clipper because they're on the project. So who's wasting money now? See what I'm saying? It's not a good idea. I mean, but whatever. I mean, at the end of the day, you know, moving it to Falcon Heavy might work. It might work. Like I said, there's people here that know way more about this than I do. Like way more. They might be right. And if they are right and the costs don't go to hell, I'll be the first one to tell you that I was wrong. You know? So, what's that? It works well with satellite bus chassis for fighter jets. Yeah, of course. So, you know, at the end of the day, you really don't want to change things. You don't want to change stuff. So, Zay, in that regard, I would have to probably go with the EUS. I'd go with the EUS because you don't want to change anything. The EUS is good enough to get what we need to get done, and it's past CDR. Let's just use that and we'll go. If I was the administrator at NASA, I would not change it. No way. No, that's stupid. I would buy more of them, though. That's what I would do. So Jacqueline is screwed, okay? That's not even just a space thing. That's systems engineering, silly Viking. Yeah, it's SE in a nutshell. NASA's SE just seems to be very more anally retentive because it's space flight, which is why I like using it. But yeah, that's systems engineering and project management in a nutshell. Yep. You're pissing away money at that point. Yep. Which is why people say, oh, EJ, I want to build a rocket in Kerbal. What should I build? I always say, I don't just say, oh, build this, I'll build that. What are you trying to do? That is the huge question. That's what all the CDR, SRR, PDR, all that stuff boils down to. What are you trying to do? Interesting, Forge. I'll check on that in a second. Let's keep going with this. Hi, saw the FAA assessment. One hop. Elon says they'll be ready in a month. So, like I said, Kim, around mid-July. That's what I've been saying that for weeks. I just want a picture of a gosh dang hot dog. Got him. It looks like they're putting up a weather vane up there or something. Look at that little baby bird right there. Look at the little baby bird. All right. Buttery biscuit base is better than hot dogs anyway. Sure. Whatever you say, Tessa. Yeah, Signer, I guess if you want to say it differently than how I just said it, I like my way better. Yeah, for the most part, dude. Okay, let's see. They're working on the pad there. Looking around. I just want a picture of a gosh dang hot dog. Fellas, what I've been saying while we've been reviewing this footage for the past 6 months is that the less scaffolding you see, the closer we are to a test. Now, with that being said, do we see much scaffolding around? I don't. I'm not sure, Force. I don't know off the top of my head. Oh, they're getting ready to pour more concrete here. You need to buy some Ray-Ban aviators? I had Ray-Ban aviators for the longest time, Wazzy. I'm not sure where they ended up, but I'll take these AOs. I like the American Opticals. You know why? You know why I like the AOs? Aviators are cool, don't get me wrong. I love those things, wore them on stream for a long time. Give me one moment. So, if we look at this footage from the Gemini 8 recovery here, right? Yeah, see that guy? See that guy right there? I like that guy. Yeah, he did some things, if you know who I'm talking about. Yeah, see? Gemini 8 recovery. Yeah. Those two guys did some cool stuff, especially this guy. That guy was pretty cool. So, if it's good enough for Neil, well, you'd be damn sure it's good enough for me. They wore AOs before they wore aviators. These are American Opticals. I think they're cooler than aviators, if you really want to know. So that was Neil Armstrong, if you're wondering. He did some things on the moon that's kind of widely regarded as a really cool thing in history. It's Bill Nelson. It's not Bill Nelson. Stop it. Stop that. Widely regarded as a pro gamer move. Yep. He crouch jumped off the limb. I knew it. C95, I knew you knew. It's one small crouch jump for man, one giant leap for jump maps. Nice bait, Naroku. See that? That's bait. Yeah, I don't know if he was using no clip, but he may have had hack grab turned on. Just a thought. Yeah, they're jackhammering up that concrete there. Yeah, good thing no one told him I rocket jump boosted. Yeah, I'm with you. Jackhammer. There's the edamame tank. Creeper, I mean, I'm pretty sure that's how that happened, yeah. And the rocket's not pointed in the right direction. So, what is the E-Dome, guys? That's an experimental bulkhead that SpaceX is working on. Right now, when they're making bulkheads, they take a bunch of strips of steel, right? And they make it into kind of a hemisphere, but without the top. And then they make the hemisphere with the top with another section of steel. It's basically 3 subcomponents. These E-Domes are basically, if you took stainless steel strips and you pie cut them, and you made that into a hemisphere instead. It's much simpler manufacturing. I'm sure if this works, we'll find it on a starship in the future. My guess is that these E-domes are way stronger and they're way lighter than experimental dome. That's what it stands for. I'll bet you they're way lighter. Like, if you look at this, there's one of the bulkheads that Starship has right now. See, like, it's a bunch of curved panels right here, and then it's a straight bunch of panels right there, and then there's a dome piece at the top. That's not what the E-dome looks like. The E-dome looks like if you took an orange and you cut it in half. It's perfectly spherical, and it's made out of much lesser material, believe it or not. You don't need to go in there and do all that welding, and you don't need all these reinforcement strips and everything. The E-dome could make a much lighter starship. A much lighter and stronger starship. How do you know that it was a jackhammer? It could have been a Jill hammer. Okay. That's it. Okay. Bird! Bird! Is it this? Question mark? That's actually absolutely it. This is a picture that Mary took. Okajiki gal. See the difference? Old and busted. New hotness. Old and busted. New hotness. See what I'm talking about? Look at how much simpler that is. Doesn't that look nice? That's the old style. That's what's running on Starship right now. It's like, kind of how Centaur's dome is, only it's not a balloon tank, Phil. But yeah, basically they're rolling out a strip of stainless, right? And then they're cutting that stainless into a pie-shaped piece, right? And then they're putting it on a jig like that and then just welding it all together. That is miles simpler, and I'll bet you that's lighter and stronger. Because of the shape. I'll bet you it's way stronger than this. Yeah, and you gain some space, Trippy. Yep. I mean, SpaceX said they want to shoehorn a bunch of engines into the back of Starship. So, will they use it for the booster too, or only for Starship? I don't know. We got to test to see if it works. Elon is being Elon today, I see. Oh, okay. That's, yep. Yeah, we've seen that, unfortunately. Yeah, silly, yeah, maybe. Good news, everyone. Maquis sales had to be stopped. Seriously, there's a design flaw. Yeah, I know the design flaw. It's shaped like a shoe. There's the mystery box. I still will maintain, guys, that mystery box is most likely a payload dispenser. Basically, they're going to take a crane, they're going to take that mystery box, bring it up to Starship 24, and just start putting the Starlink satellites in. I think that's what's going on. Shoe moment. Guy gives 0 fricks. I love it. Yeah. It's truly in it for the Maymays, which is pretty sweet. Yeah, doing some testing on the sticks there. I don't know, Jim. All right, cool. So we got a couple more NSF videos to see here. This is the next one. This one is done by Nick and the NSF robots here. It's a nice shot of some water. Oh, with that launch pad in the background too. That's pretty cool. That's pretty neat. It's a much nicer design, Forge. Yeah. Looks like Booster 7 may roll out on Thursday. That's coming from Mike Baylor. Okay, cool. Put a launch pad in my water. Like I said, you don't see a lot of scaffolding left there. Tells me that we're gearing up. Not you and I, SpaceX, but you get the idea. How far are these cameras out? This camera's, I don't know, 1,000 feet away from the pad. There's a road right next to the pad. There's State Highway 4, SH4, is very close, so you can get some pretty good pictures. It's a public road, so like you could drive right up next to this launch pad, which is not something that you can do at the Cape. They get mad at you when you do that at the Cape. I wouldn't know nothing about that though, never done that. It's interesting though that the ship quick disconnect arm still just has the umbilical for fueling Starship. They did have a vehicle stabilization system on here, and then they didn't. They took it off after they did a stacking test. You can still see though the slots and everything where it was mounted to. I wonder if they're going to replace that, Burbs. Pelican, come on, Pelican! A couple of days ago, if you missed it. First components of Mechazilla's 2 chopsticks have arrived at the Roberts Road facility. They are located near the tower sections currently under construction. Oh boy, oh boy. Very nice. They left a paper on it. That's insulation, you doofus. Hey look, there's a gantry crane in there though. I like gantry cranes. Or if you become friends with Elon, you can see them in person like everyday astronaut. How much lead time does SpaceX need to give the FAA now for launches? Well, they have to apply for a license first, PS. That's the next step. Got to apply for licenses now. Okay, voice. Now is not a good time to go away. Please come back.
Listen, Tranquility Base here. The Eagle has landed.
Paste Party. Paste Party linked us a picture. What does the picture say? The Fibonacci sequence. Gießen moment. Gießen moment, am I right? Gießen moment. Oh, it's bad when you're posting pictures of industrial equipment, mate. He's like, hey, what's up, guys? Thanks for the tip, dude. I appreciate it. And you know what? I'll thank the other people that have tipped too. Mr. VFT and Mr. Ono. Tip of money for the Spaceport America Cup thing. Thank you very much, guys. I can't thank you enough. It's gonna be nice. There are 2 kinds of people I can't stand in this world, Pythos. People that are intolerant of other people's cultures. And the Dutch. Oh, those who pee in the shower and those that lie. Yeah, that too. That yeah. Here, look at this booster. Isn't that nice? That's good.
Discovery, go at throttle up.
Still couldn't believe SpaceX will have to write a book about the Mexico and U.S. Civil Wars. Hey, history's probably a good thing to remember. That's just a small thing to do. No problem. SpaceX will belt that out in a second. Make the interns do it. Get done real quick. Kevhawk, 17-month resub. Tip, don't eat yellow snow. Okay. especially in the middle of June. I have questions, boys. I have questions. What spurred that What spurred that conversation? I'm just gonna stop talking for a second. Oh yeah, Tomas. I agree with you. I should probably. I mean, dude, I don't know. I wonder. Oh, okay. And here we go. Yeah, this video rocks. Or is it granites? Propellant production. Yeah, I think they're going to make locks on site, Jim. They can do that with the solar panels, I think. I don't know, Foz. Maybe that's up to them. You'd have to go ask them. Forge, do I want to know? It's just people complaining about things they know nothing about. I'll have to go check. Alright, T-Man, let's see. Looks like they're putting the booster hood back. Okay, we got a couple more of these videos to take a look at. The booster hood was reinstalled there, which is cool. In the meantime, what is this article here? This is a Business Insider article. Hang on, fellas. I'm gonna peruse this real quick. Do these... You're wearing my sunglasses. No, you're wearing my sunglasses. So let me get this straight. We need to shut down SpaceX? I don't think they said that. Unless I have to scroll more. I don't... Let's pitchfork Dave Cortez. No, let's pitchfork nobody, dude. That's stupid. That's something... Dude, bullying people just because they have a different opinion than you is something that children do. I don't do that crap. Someone from the Sierra Club said it. Well, okay, so the people that are pro-environment are upset about this. That's fair. The FAA disagrees with you, so I mean, I don't know what you want. I know what you want to hear. What is like? All right, I'm kidding, my man. Yeah, I know, Glitterel, but you can't be. I know you're kidding, dude. But I can't be, dude. Even if like, dude, I can't be. I gotta be careful with that stuff, dude. I think people do that way too much in this day and age, man. It's not cool going after people like that. You know. Nice, T-Man. But yeah, I mean, guys, I've always said this. I've always said that, you know, you really need to understand your environmental impact. And I'm pretty sure that this, you know, the FAA did a pretty damn comprehensive assessment. They did a comprehensive assessment because, like I've always said, this is the first of its kind. You really have to be sure. You cannot leave any stone unturned. Except with the environment, because you don't want to screw that up. Hey, you know, I understand people want to preserve wildlife, but my thing is always that you can do both of these things. You can do both of these things, and if anybody says that you can't, well, I just literally point to Kennedy Space Center and be like, yeah, you absolutely can. Kennedy Space Center is on a wildlife refuge. If anything, it has protected the area in Central Florida from being destroyed by humans because you have to be far away from a rocket pad from a launch pad when a rocket goes off. If anything, that has preserved nature in Central Florida. Here, I'll show you. I'll give you a good example. We're looking at KSC right now. Look at the rest of Florida and then look at KSC. What's the difference here? Green. See what I'm talking about? I would argue that SpaceX being there is going to preserve that area and prevent it from ever being developed for anything else. But like I said, I don't know. I'm sure these people, whatever problems they have, I'm sure it's not unfounded. You know, but they're, like I'll say at the end of the day, it's not one or the other. It's not no rocket launches or a bajillion rocket launches, even though the spaceflight fan in me wants them launching a Starship out of Boca Chica a day. You know? That'd be really cool. But, hey, it's on the cards. Sometimes you gotta compromise. But, see, the funny thing is that SpaceX doesn't have to. They can just ship Starships to the Cape, which I think is what they're going to do, and then just launch them there. You know? So, look at Cape Cod. Look at Joint Base Cape Cod. Actually, I'll desert that. Otis is a very good example of that because, yeah, dude, Cape Cod, man, we went down to Hyannis a couple of weeks ago. Holy crap, that place is built up. Like, just on a quick side note, like, Cape Cod, there used to be nothing out there. Now look at this. Look at Hyannis. Look at Hyannisport. That's insane. The traffic was terrible. On this road right here, all the way to the roundabout, oh, it was garbage. You should hit me up. That's my house. Where were we? I took actually the reason why we were down there, I took my dad to Alberto's. You know Alberto's on the main drags? Holy crap, that place is good. Seriously, you want good Italian food? Go to Alberto's in Hyannis. And you gotta say it, Alberto's. You gotta say it like that. Oh, it's fantastic. Yeah. The Cape is some of the worst traffic I've ever seen. Yeah, because all the yuppies move down there in the summer. Hyannis, you jagoff. We only have 2 roads. Yeah, 1 and 2. The train museum down there is pretty baller, though, I will say. This is cool. All the Bud cars. Did it have a car pack? It had a shut the hell up pack. Yeah, freaking Route 3 and yeah, that's it. But yeah, I took my folks down there. Yeah, it was awesome, dude. That's such a good restaurant. Anyway. So, guys, you know, it's interesting that all these people are like, oh, they're going to ruin the environment more. They're going to ruin the environment more. When Kennedy Space Center has been there for 50 years, and it is a shining example of how rockets and how spaceflight and nature can coexist and form a symbiotic relationship. Which, I mean, I don't know if that's been explained to these people that are, you know, pissed off about the FAA giving SpaceX the go-ahead on the programmatic assessment. Like, I don't know if they've shown this, or, I mean, I don't know. Maybe they just don't like Elon Musk. You can't make people like you. You know what I mean? You can't do that. In fact, if you try to make people like you, they're gonna hate you even more. So, yeah, you can't please everybody. You know. His replies. What is this? Yeah, dude, don't try to get people to like you. They'll end up hating you because you're being something that you're not. Don't do that. I'm dead serious. Don't do that. The dark sky rating is going down a couple Bortle values, that's for sure. Like I said, Jim, you can't please everybody. All right, what is this guy saying? Let's see. So the FAA says Elon Musk's SpaceX must take more than 75 actions to mitigate insignificant impact for Starship and Super Heavy that it will have on the surrounding wildlife refuge, public beach, and endangered, threatened species that reside there. 75 plus. I could see this headed for court. Why do people keep saying this? I am more for this restaurant. Oh. Al dente's. Yeah, I got you. Because they're armchair lords and see, once again, fellas, like a lot of this stuff they've been working with the FAA on. It's not. I don't understand why folks don't get this. Like it's very strange. It's all like it's like SpaceX submitted a book report to the FAA, and the FAA's been reviewing it for a year, and SpaceX has just been sitting there twiddling their thumbs. That's not how this works. It's not how it works at all. They've been going back and forth. They always have. You know, that's how stuff works. This is like you don't just sit there and go, oh, I hope my report was good enough. No, they're working on mitigating things as they speak. You know, like I don't understand here. Oh, well, I could see this headed for court. Well, they're gonna get sued. Well, no, they're not. If anybody's gonna get sued, the FAA is gonna get sued because they said they gave it the go-ahead. As long as SpaceX abides by those 75 mitigations, there's no significant impact per the FAA's rules. If it turns out to be more than what the FAA ruled, well, they're the ones that said go for it. They're the ones that are liable in that situation, from what I understand. Now, don't get me wrong. I'm not a lawyer. I have no freaking idea. But that seems to be what's going on. I've been studying a little bit of real estate law lately, if that helps. Because buying a house does that. Why don't you hate Elon? Are you an Elon supporter? Yeah, I know, right? I'm more of an expert in bird law myself. Visual, you get that thing I sent you? I don't understand. Like, yeah, Supercraft, I don't know. I don't want to sit here with this. I don't want to sit here and say I'm like the utmost confident that all these folks are wrong. I don't know. They could be right about something. The truth of the matter is that I don't know better than the FAA about laws that pertain to the FAA. I don't. I mean, but I'm pretty damn sure that the FAA wouldn't know the stakes involved with approving a spaceport like this. So what I've been saying is that the entire time is that the reason why the PEA got delayed for so freaking long is because they needed to make sure that they were operating within the confines of the law, because this is the first commercial spaceport of its kind. No one's ever done anything like this before. I mean, look at that thing. No one's ever done stuff like this. You know, so the implication here that these folks are just chilling around on the internet, like, know a little bit more about laws, it's just a little bit funny to me. You know, I don't know. Like, it's a little weird. You really think you know more? Like, I don't like Elon Musk for various other reasons, but say so. Yeah, I mean, look, ARJ, do you have a best friend? Are there things you don't like about your best friend? But they're still your best friend. I'm not saying Elon Musk needs to be your best friend, but I'm saying what you're saying is right. Look, you don't, you know, like I also don't want to say, you know, you can like parts about a person, you can hate other parts. That happens. That happens all the time. You know, like, but simultaneously, at the same time, I don't just want to sit here and say, oh, these people are causing a hubbub because they don't like Elon Musk. Like, I don't think that's the right thing to say either, you know? As much as we want to kind of pretend that everything's crazy and this is ridiculous and people are, you know, the world's going to hell in a handbasket, like, you know, we're ruining the environment. And don't get me wrong, environmental impact should be noted and documented and understood. That's how we learn. Hello? Like, that's usually not how this rolls. It's not, especially not with the FAA. The FAA is just there to make sure that everything is safe and the environment's not screwed up too much. Because if you go and screw up the environment, like if a starship crashes into their drinking water supply, you're going to have a big problem. And guess whose fault it's going to be? It's going to be the FAA's fault. So we got to, like, I have to give the benefit of the doubt here. They have to, like, they took a year to get this done right. 17,000 freaking comments, and they reviewed every single one of them. That's a lot of work. But to sit here and imply that, you know, like, well, they're going to be open to lawsuits now, like, that's just kind of weird to me. I don't know. Too much hyperbole, trying to make a gray situation look black and white. Yeah, Barkwell, we tend to do that. Was the EPA part of the study? There was interagency consultation, Dragon, absolutely. Yeah, duh. What do you think the FAA knows about the environment? They know nothing about the environment. They go to the EPA. And they did interagency consultation with them, and they checked it against the NEPA, which is the National Environmental Protection Act. It was one of the... It was a piece of legislature that helped make the EPA for the most part. EVA. Still thinking about spaceflight stuff. Sequels. Jeez. Yeah, they, like I said, this was about, I'm willing to bet that this programmatic environmental assessment was about as scrupulous as you could possibly be. What the hell does that word mean? I don't know. I just like saying scrupulous. No, it means in depth. Like, no stone unturned, every detail. No details overlooked. I'll bet you it was like that on purpose. Because when these people try to go at them and say, the FAA, you did this is your fault, the FAA is going to be like, no, we didn't. No, we didn't. They're working within the confines of the NEPA. The EPA and the NOAA says this. Nice try. Scrupulous. Scrupulous! ergo, concordantly, vis-a-vis. Anyway. I just like throwing big words, and I just thought it made me sound cool. I am the architect. I invented the Matrix. Boom! Still a funny sketch to this day, Ben, yeah. I'm just tired of people getting sorted into lists of heroes and villains when most people are neither. Yeah, Barkwell, I'm with you on that one. It gets a little... It gets to be a little much at times. That's why usually when I see a hot button thing like this, especially when it comes to space, tell everybody to calm down. It's not as crazy as everybody's making it out to be. It really isn't. It really isn't. You know, like a week ago, everybody was whining that the FAA was taking their sweet time. Okay? Oh, it's a conspiracy. They just want SLS to launch before Starship. Blah, 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 blah. Dude, I heard it all. Now, where are those people now? Those people are gone. Now it's the people that were saying, well, you know, you got to be very detailed about the environment. You got to be the people that were playing it cool a week ago are now freaking out. What gives, guys? What gives? You know, like... Yeah, there you go. Falcon 9 go brr. Yep, we covered that already. So, Forge, what was this other thing here? So this is coming from ESG Hound. Okay, lost in the SpaceX FAA hubbub yesterday is that SpaceX doesn't have a way to handle tens of millions of gallons of deluge water without getting an Army Corps permit that will take a year plus to approve. They leave the option open for a no deluge option, but that seems not good. Well, okay, I'm confused here. There's pad deluge systems and then there's sound suppressors, okay? Pad deluge systems are above the base of the rocket, okay? The pad deluge system is to make sure, pad deluge is used for sound suppression, to be fair. It protects the pad, it film cools the pad. You ever notice that rocket engines are really, really freaking hot and how the pads around the rocket don't really melt? Well, they spray them down with water. Spraying them down with water helps absorb the steam because water's really good at retaining heat. Really, really good. It sucks all the heat out of the rocket engines, and instead of melting the metal, it heats the water up into steam. The pad deluge system also protects the rocket from acoustic vibrations that can bounce off the ground right at liftoff. Basically, water is also really good at absorbing sound. That's why submarines have sonar. It absorbs sound very well. Submarine sonar can pick up loud aircraft because the water absorbs sound very, very, very well. It's really good at that. Ever try to talk underwater? Like, you can hear somebody from a good way away, like, it sounds like a murloc, but you get the idea, right? So, that's a deluge system. Deluge systems don't need that much water. Okay, there's a pad suppressor as well. Okay, a sound suppressor is a different thing. Okay, the sound suppressor is usually put into a flame trench. They spray water into the flame buckets. That makes it, that basically makes it so you don't melt the damn flame trench for the same reasons why you don't melt the pad, and it also does dampen the sound. But it's mainly there to just burn off all that heat that the rocket engines put out. Rocket engines convect a lot of heat, especially down here. Yeah, convect. They make a vacuum and they move heat around really, really fast. So, here's the thing. You need a sound suppressor, right? The sound suppressor is below the pad, and it usually sprays the flame bucket. That's where you use most of your water, which SpaceX does not have. Yeah, Electron, I thought you'd dig that. There's a deluge system, and then there's a sound suppressor. Those are two different things. Even though the pad deluge system, the pad deluge systems do dampen sound. That happens. But that's That's more for protecting the rocket from itself. The sound suppressor is the thing that's in the flame trench that protects the flame trench and quenches the sound of the vehicle, so it's not too loud that it rumbles somebody's eardrums out. That also does suppress sound, as the name implies. They both do, but those are two different things. So what's Hound talking about? I mean that. Like, what are you talking about? If they don't have a flame bucket, they don't have a flame trench. They're firing this thing bone dry. The rocket's sitting like 10 stories up in the air. If it's sitting 10 stories up in the air, you're only going to need a pad deluge system. I can give a good example of that here. If people are familiar with the Saturn 1B milk stool, right? The milk stool is a very good example of what I'm talking about. When you don't have a, here's a good picture. When you don't have a flame trench because your rocket is high up off the ground, you don't need as much water. There's your point right there. This thing wasn't even shooting its exhaust into the flame trench at all. It just shot it out to the sides here. That doesn't need a sound suppressor. It just needs a deluge system. You need way less water. And I think that's part of the reason why SpaceX doesn't want a flame trench, because it'll take more time to engineer it. You can milk Saturn once? Yeah, well, look, it's the color of a cow, Tessa. What are you, dumb or something? Jeez. Why do you think the rocket is black and white? Cow's black and white, rocket's black and white. Duh. I thought you were smart, man. Jeez. That's a little bit weird, Hip. Okay. But cows are brown. Yeah, those are the ones that make chocolate milk, dude. Do I have to think of everything? What are you guys doing over there? Jeez. SpaceX tested this. What is this? Yeah, like I said, they're not moving as much water as you might think because there's no flame bucket. There's no flame trench. So yeah, okay. I'm genuinely curious if there's any good explanation as to why no deluge could possibly be fine for the largest rocket in history. One of the many reasons I'm sticking with no orbital launches from Boca Chica until 2024. Does Soyuz not just use a pit? Soyuz only has a deluge system, someone. Yeah, for the same exact reason. I would like to know why the yearly donation to the wildlife organization was included in the assessment. Call it charity. I know who he is, Creeper. Yeah, he's part of the They Will Be Sued crowd. Like, I don't know, man. I don't understand. He could be right, he could be wrong. I have no idea, dude. I don't know. Like, it's just... Guys, something that I never try to do, even when I know what's going on. Like, I know that SpaceX is trying to target July. Elon basically said that yesterday. But I knew that a couple of days, well, I've known that for a couple of weeks now. Why? Do I have somebody at SpaceX telling me things? No. There's things to look for. They wouldn't load methane and they wouldn't load oxygen into the pad at Boca Chica if they weren't sure about launching. Now, one could make the argument that what if they're just doing static fires, EJ? Well, why would they load up enough to get into orbit? Trucks have been going in and loading propellants into the prop farm at Boca Chica for like 3 weeks. You telling me they need all that just for testing? Fat chance when most of the testing gets done at McGregor anyway. Now, do I think they're going to static fire it? Yeah. Why would you need all that for static firing? You could just use an ullage gas and tank it that way. Which is exactly what they did with SN5. SN5, SN6, SN8, SN9, SN10, SN11, and SN15. They never filled those things up full with fuel. No. How are you going to simulate landing conditions when the thing has a full tank of gas at liftoff? That makes no sense. So like I said, I didn't know. I don't know when SpaceX is going to fly, but I have a pretty damn good inkling that they wouldn't be loading up, they wouldn't be buying all this liquid methane and liquid oxygen if they weren't sure. See what I mean? You can use some logical deduction there. And look, Elon came out a day ago and said, "Yeah, we're aiming for about a month." He said that yesterday. About a month, middle of July. It's not rocket science. But what I like I said, I could have been like, "Yep, I knew this. Middle of July." I always say the middle of July is what I'm thinking, and then give you a reason why. Why do I think it's going to be in the middle of July? Well, the propellants, what I just told you, that's a pretty reasonable indicator. You know, that it's not a stretch. It's not a stretch thing. And I've entertained other things that possibly could be. I've entertained this, I've entertained that. Like, it could be just for testing. It could be they're testing the prop depot. They could be using it for plumbing testing. They could be. But the timing with the FCC filing for launching Starship into space, and it also jives very well with the programmatic environmental assessment. Which tells me if the Starship is ready for a month, they'll probably do some testing, but they are gearing up for an orbital flight. The propellants would be here weeks in advance, just to make sure that you have them so you can go right when you're ready, which tells me that SpaceX is going to apply for a license for Starship's orbital flight test. And guys, let's use some logical deduction here. How long do you think the licensing process is going to take? Anyone? They're targeting mid-July. It's not a hard answer. It's going to take about a month. 2 weeks. Yeah. A month at the very latest, right? This isn't rocket science, man. You can look. There's stuff there. You just got to know what to look for. But pulling some crazy deluge thing out of your tail and then using that to reinforce your point based off of a complete stretch of a system where you don't even know anything about is ridiculous. I don't know, but I'm not going to sit here and say that, the guy is wrong 100%. I don't know if he is. He might know more about this than I do. That's one thing that, fellas, it's a really important life lesson to learn. And I don't mean to be like, well, you should do that. I don't mean to be boomer EJ on here. You know what I'm saying? But there's always going to be somebody out there that knows way more about something than you. Way more. So don't be a dick. I find that these people that speak in absolutes, like, oh, well, they're never going to launch. I'm firm 2024. I know for a fact that, yeah, okay. Yeah, you know for a fact. So that tells me two things. One, either someone's telling you something and you have some inside information, in which case it's probably not your opinion because someone told you it. Or two, you're making up stuff. Or three, I guess we'll add three, you could be right. I don't know. But I'm not going to sit here and be like, oh, this guy's an idiot. I don't know that for sure. I don't know him. I've seen him tweet. And if it's one thing I've learned, people's online persona might be a little bit different than how they are in real life. You know what I'm saying? Yeah, Bon, it's very interesting to me that see these people speak in such absolutes, right? The guy basically says, I don't know. They might get, I'm really genuinely curious, but I don't think they're going to launch until 2024. This puts me firm in this. I'm genuinely curious. No, you're not. You're not curious at all. Don't lie. Come on. Hey, Alucard, what's going on? It's ridiculous. Like, how could you possibly know this? How could you possibly know this? And then you don't even try to throw monkey wrenches in your own idea. You don't even try to prove yourself wrong. You just say, well, I don't think they're going to do it. I'm genuinely curious how they're going to do this. I don't think they're going to do this. That sounds like cherry-picked information to me. That's not being scientific at all, but I could be wrong. I'm not even saying that I'm right here. This isn't about being right. You know, that's the point that I'm trying to make. It's not about being right. It's about making sure that we understand what's going on. That's the important part, right? Like, I mean, that's the important part for me. I want to understand what's going on. You don't try to learn something by proving somebody wrong. The funny thing is, you learn something by getting proven wrong, usually. It's the reverse of that. So how can you be genuinely curious and then stick to an absolute conclusion at the same time? That's not being scientific. That's the opposite of science. How's the ET1 project going? ET1, Zay, what do you mean? I think they're targeting July, Foz. I think that's a reasonable thing to understand. SpaceX is going to want to try to get that Starship off the ground as soon as possible. Elon said that multiple times. That's not some crazy revelation, man. Do you have to be a sub to post links? Niroku, you got to get perms from my moderators. ULA, we are launching Vulcan this year. Eric Berger, Vulcan is launching in 2023 because I know better than ULA. Yeah, Phil, that's very strange. The guy apparently has a master's of science for environmental engineering per his site. See what I mean, Thomas? You don't know. Everybody here is saying, oh, this guy's an idiot. This guy's an idiot. You don't know that. He might be right. Just because he says something that you don't like doesn't mean he's a moron. I mean, sometimes it does, but I don't. How? Like I said, I've seen him. I've talked with him about it. He does like rocking the boat. That's what he does. You know, like that. I've noticed that. But he might be right. He could. I wouldn't rule it out either. Remember Elon time, so him saying July. Creeper, yeah, we can say, oh, Elon time. You can say that all you want. And that's fair, but also, this pad looks like it's pretty well endowed, ready to go. They wouldn't be putting the covers on here if it weren't. Think about it. Once again, let's just use quick using your noodle for a second. I know it's Twitch and I know I'm your entertainment. I get it. I could be your background noise too. Just that's fine. Use your noodle for a second. Would they be putting on the covers if they weren't sure that pad's ready to go? Think about it. If you're working on a car and you still need to change the oil, do you close the hood? No. No. They wouldn't be doing this stuff unless they were ready to go, or at least they think they're ready to go. Now, Creeper, here's the thing. With spaceflight, you're going to have unknown unknowns. No one's ever put a rocket together like this. No one's ever tried to launch something like this on this scale. It's never happened before. So there could be an unforeseen delay. And I think that's where that's where Elon time comes into it. Because Elon factors in what's possible with everything going right. He's a probability guy. You've seen it. You've seen him talk about it in Tim's videos. Just in your travels, you go watch, he thinks in probabilities. So I think his time scales are based off of everything going right, which is not something that happens in spaceflight all the time. It turns out this stuff is complicated. Ask Chris Kemp. He knows. The guys at Astra, they know this stuff's complicated. It's hard to do. I trust SpaceX and the FAA more than just one guy. Yeah, Thomas, see, that's what I'm saying. Great. He has that degree. That's fine. That's awesome. I have a degree in computer animation. Are there better 3D modelers than me out there? Yes, abso-freaking-lutely. Do I think I know how to model things better than a 3D modeler that works for Rockstar or something? Hell no. They're way better than I ever could be. So, you got to remember, this guy, he has that degree, right? But there's a bunch of people that work at the FAA that also have this, and they said it was right. How is trying to buy the shuttle ET project going? I haven't heard much on it, Zay. I have to go back and check in. I'm better than you at modeling. No, you're not. No, you're not. Get back to work, Code Monkey. Sorry. But yeah, I don't know, man. It's very interesting to me how people think they know more. That's a mistake I used to make all the time. That I know more. I know more. I know more than you from my experience. That is a terrible way to look at things, especially when it comes to stuff like this. Promise, like, okay. I I mean, you know what, Brownie? You probably are at this point, man. Look at how rusty I was when I put that T-38 together. It's unbelievable. How's the plane coming? It's getting there. It's getting there. We got a couple more videos here. I think, let's go here. Once again, guys, this footage is coming from NASA space flight. What did that guy do to get all 5 people? Sequels, he says stuff that... He said Houghton says stuff that people don't want to hear. That's the truth of it. He says stuff that people don't want to hear. Now, that's the truth. Honestly, he just says stuff that people don't want to hear. SpaceX's programmatic environmental assessment just passed. Everyone's like, yeah, good, we're ready to go, let's go. They don't want to hear somebody saying it could take another year and a half, right? That's the honest truth. Now, don't get me wrong. Look, I take ownership of my actions. If I'm wrong about something, I tell you. I said that I think they're going to do this. I'm wrong. I am 100% wrong. I will own up to my mistakes that I make. I try not to make many mistakes when I report to you guys what's going on in the spaceflight industry. I think that's very important. I've not seen that guy take accountability once. But then again, I don't really follow him too much on Twitter. My exposure to the guy has been through you guys. So it's, once again, that's not an accurate assessment of character. Understand? Did you already go over the environmental impact assessment? I haven't been here for the whole VOD. Yeah, Naroku, I did. I got through most of it. I started Space News with it because people wanted to talk about it, and we're still talking about it, but that's okay. Evening, Maverick. That's Shades. Thank you very much. Now, what's up, FX? How you doing? I wonder how long the Mars is great, Elon is great comments cost of time and effort. Well, yeah, Foz, that's something that I got right, but I said it for the wrong reasons. I said that all those comments are going to end up hurting SpaceX because they have nothing to do with the environmental assessment. Most of the comments on the FAA's programmatic environmental assessment were just, SpaceX is good. I think SpaceX should do this because space is vital to humanity. While that is a correct statement to say, that has nothing to do with the environmental impact. That I said at the time that that'll actually end up hurting us. And I couldn't say the reason why. I wasn't smart enough to say why because I don't have a crystal ball. I can't freaking predict the future. But what it ended up doing is hurting us in the fact that it took a freaking 3 months to get through 17,000 comments. But Elon did say to go and comment on the report. You know? He did say that because he wanted it done because he wants his rocket to fly. So, I don't know. Make of that what you will. Doing good, home for the week, then heading to the state below you. Rhode Island or Connect I cut? CT? Ah, yes. Contested territory. What? It's halfway between here and New York. Screw them. Frick off. Go back to Long Island. Go back to Long Island, gay guy. Get the frick out of here. CT spawn. What? Push B? Anyway, nice to see Blue use the same company SpaceX used for the drone ship. Yeah. So, fellas, once again, the thing is, I think it's important to understand that if anybody's speaking in absolutes, even Elon, because Elon time, right? Anybody's speaking in absolutes, like this is definitely going to happen. Nobody has a crystal ball. Just be careful of that stuff, especially in this industry. You know, guys, I know for a fact that misinformation gets peddled all the time. There's misinformation everywhere. And now, don't get me wrong, that's not some crazy conspiracy. Sometimes companies put out misinformation to see if people are telling people stuff that they shouldn't. That happens all the time in an ITAR-protected industry. Rockets, at the end of the day, is defense. You might not like that, but that's the way it is right now.
Discovery, go and drive.
So I know that a crazy amount of information that does get released is not right. That's not true. And my check against that is doing this thing called using your brain. Like, if it's too good to be true, if that information is too good to be true, it probably is. Right? Occam's razor. That's what that's called. The simplest solution is probably what happened. If it's too good to be true, it probably is it's probably some misinformation that gets floated around. Right? That's my general rule of thumb. The other thing is just people speaking in absolutes. Oh, we're going to do it. This is going to happen. The programmatic environmental assessment, not even Elon said he was sure that it was going to pass. He said, because he's, once again, a probability guy, that's how the guy thinks. He thinks in probabilities all day. He says that we have a good chance. We have a good chance of passing. There you go. That's a great picture. Great picture, Papa Bear. Yeah, they released a YouTube video of that thing getting manufactured. It's pretty freaking cool. I mean, Sleepy, considering that SpaceX is using some parts that is also used for ICBMs. Guidance systems. Guidance systems are one of the most well-protected ITAR things around. Yeah, guidance systems, man. What is Falcon 9 but a precision munition that doesn't blow up when it hits the ground? I mean, sometimes it does, but it stops. The whole point is to stop before you hit the ground, right? How's that different from a guided munition? That stuff is very protected. That's very important. You don't want people with that kind of tech. That's not a good thing. I'm 120% sure that this statement is worse than absolutes. At least they max out at 100%. Yep. How many rockets blew up before it stopped blowing up before it hit the ground? Yeah, I don't know. Yeah, a lot, right? Anyway, let's watch this now. Let's this last NSF video, and then we'll see if there's anything else around. To be honest, you could probably do a decent guidance system with the Raspberry Pi. Yeah, Tessa, you probably could. And if it goes over 1,000 feet and you do it without asking, you're going to jail. Or at least getting a pretty gnarly fine. Only Siths speak in absolutes. That's right, Dustin. I didn't say should, only could. Yeah, and I'm supposed to sit here and agree with you so somebody actually goes and does that? Yeah, no. I like my first answer better, dude. I like my first answer better. Okay, that's the umbilical for super heavy right there. I mean, look at this. Look at the size of those prop lines, man. Filming the umbilical. This is on, I think that's on the transport or testing stand right there. It's so strange to me to see a rocket umbilical held up by just a regular chain pulley. Isn't that nuts? There's some nice fuel lines. Got a couple for the F-250. Dude, how much fuel do we need? What motor would it have if we need to deliver that much fuel? I mean, the fuel lines on the truck are like that big. Like 3/8 of an inch or something? Actually, it's metric. Most of that truck is metric, believe it or not. How much fuel do you want? Yes. Sure, Elfish. I don't think you'd need a line that big. Fuel line would weigh more than the damn car. Think of the fuel pump! Actually, Goalie, you want to know how these guys move prop around? They don't have a pump. That pump would need to be insane, right? You know how they move it around? They heat up the methane. They use an electric coil and they heat up the commodities inside of the tank. And that expansion makes pressure, and that gives you pipe head, and that fills the vehicle. Yeah, that's the way that they do it. That coupled with valves. Yep. Because a pump would be... Dude, can you imagine how strong a pump would need to be to fill up Starship that quickly? There's easier ways to do it. I mean, dude, they... Like, think about Falcon 9, for instance. Falcon 9 gets fueled up in 45 minutes. That's like an Olympic swimming pool worth of liquid oxygen in RP1. Does it in 45 minutes. That's pretty damn fast. You know how big of a pump you would need to do that? It's not even worth it. Just heat the commodities up and it'll work. Now the RP1, that's a little bit different because it's not cryogenic. They could pump that in, but the RP1 tanks are filled way before the liquid oxygen tanks are, aren't they? Mama, you think you got it figured, boy? You wrong. Imagine you need a rocket engine pump to fill a rocket. Bingo, Supercraft. Yeah, it do be like that. You need a pump as strong as the damn turbo pumps. No. Thermal expansion is way easier. Way easier way to do it. So they will have one of these in Florida too? Multiple ones in Florida from what I understand would bite, but I don't know that for sure. Hey. Some of that stuff is already showing up. Yep. Dude, look at that. Is that eye candy or what? Even simpler, have the commodities in an inner bladder tank and just pump the fluid into the outer hydraulic pressure. I mean, Tessa, that's how monopropellant systems work. That's how pressurized monopropellant and hypergolic thrusters on orbit work. Bladder tanks. Yeah, they have a helium. They have a helium tank. And they have a helium tank, and they have a hydrazine tank, and then they have a helium tank and a nitrogen tetroxide tank. The nitrogen tetroxide and the hydrazine COPVs are bladder tanks. They just pump helium in, they squeeze the bladder, and you make pressure. And then that system pressurizes, and then you can use the thrusters. The thrusters just have solenoids like a fuel injector that just clicks open and close. It's literally a fuel injector. It's just a very, very spacey fuel injector. Just like the one that you see on your car. Now, RCS, right? RCS is it only works in pulses. Like sustained fire for an RCS isn't really a thing. So it really is a freaking fuel injector. I mean, look at a picture of a Draco engine. It's a damn fuel injector. I'm telling you. Look, see it right there. There's two of them. They're freaking space fuel injectors. Oh boy, Pinterest. That's the sound of dog poop. Oh boy, Pinterest again. Lovely. I hate that website. I hate it so much. Yeah, it's just, see, there they are. There's one on the top and then there's one on the side. The reason why there's one on the top and why there's one on the side is because they want the propellants colliding with each other inside of the combustion chamber. It gets you good atomization, or it gives you good combustion in this case because it's a hypergolic thruster. Well, for the uninitiated, if you don't speak rocket science and I just said a bunch of gibberish, basically when the liquid fuel and the oxidizer hit each other, they explode. They're two chemical compounds that when they combine, the chemical that does chemical work, it basically combusts. You ever seen Die Hard 3? Like that. Exactly like that. Makes a nice pop. So yeah, they just have, it's basically a big water gun that's shooting, not water, but propellants into that combustion chamber, and it's back pressure, just like you pump up a freaking water gun. It's the same idea. Really cool stuff. It's a binary liquid. Buildings. Yeah, Force, I can't stand them, dude. I can't say everything is like, hey, you want to view this picture? Sign up for Pinterest. I'm like, no, I don't think I will. Is it bad if I can picture the scene in the police station where he throws the pin with the 2 compounds on it? Charlie, you're gonna be wearing that up your butt! It's like that, but honestly, you don't even need to mix. Think Die Hard 3, but they explode right when he pours the one on the other. Yeah, right when they mix, they explode. They pop. The Timbit about the Merlin engine is really cool. I told you. Yeah, it's awesome, isn't it? Merlins are really, really cool engines. Genesis for SpaceX, to be honest. Oh, there's a welding jig right there. See it? I mean, Tom Mueller's a freaking genius, dude. So smart. There's more than one Die Hard movie? No, there was 2. Die Hard 1, obviously. And then there was Die Hard with a Vengeance. I don't remember any other Die Hard movies getting made. Red light, green light. Yeah, Gil, right? Sure, Zay. Why not? There's the... I think it's a payload change-out room for Starlink satellites, but I could be wrong. You know what? Live Free or Die Hard was not bad. I will tell you that, Stevie. Live Free... Die Hard 4 was actually pretty good. I didn't mind it. It was a good movie. Somebody told me Die Hard 2 was their favorite movie. We're no longer friends. Good man. Good man. Yeah, something, I don't know, Tessa, it must have not been very popular or something. I don't remember that. 5 total? No. I just said there was only 2. You didn't listen to me. Juice Spot better than Indiana Jones 4? They didn't make a 4th Indiana Jones movie. They didn't make a 4th. They didn't make a 4th Indiana Jones movie. I don't know what you're talking about. Why are they still filling up the suborbital site? Well, T-Man, let's use our brain for a second, okay? This is what I mean. Why would they be filling up the suborbital site? We know that these 2 fuel systems are not connected. They're not connected. There's no pipes that go from the suborbital pads to the orbital pads. We've seen them fill up fuel for the orbital pads. I think that with the amount of propellant that they loaded, that it's most likely that fuel, that liquid methane, liquid oxygen, liquid nitrogen, is probably going to be used for the orbital test. Now, we know it's not connected, so why would they fuel up a separate system that's on these suborbital pads? They're going to test fire some starships. I think that's a pretty reasonable thing to assume here, because we see them loading freaking... What is that, liquid nitrogen? They're loading liquid nitrogen in. So at the very least, they're going to be doing tanking pressure testing, which is what we've seen. They just tested, what was it, Ship 24. They did pressure testing for Ship 24 at the suborbital pad. Nope. Phonesister, I don't know what you're talking about. They canceled that race, so I don't know what you're talking about. Now, we see liquid nitrogen here. What's in this other truck? I didn't see what the placard was. That's the end of the sentence. Ugh, get that porta potty out of there. Oxygen. See? Static fires. That's a reasonable thing to assume. They're also working on installing the new quick disconnect onto suborbital pad B for static fire testing of Starship. Hang on, let me back it up here real quick. LMT 800. Not a bad try. That guy's going fishing. From what I understand, Elon said the second stack will be ready in August. So first stack flies in July when the second stack passes in the suborbital test pads. Like I said, If you use your brain, the evidence is here. We have all the information we need to come to a reasonable conclusion. And that reasonable conclusion has nothing to do with the year 2024. Do you mind me putting in some rush, or do you want to save the VOD? I always want to save the VOD, Zay. I'm not making a habit out of nuking the VOD despite playing Top Gun last night. Yeah, Dave, yeah, that's what happened. Note pieces of the experimental dome right here. See? The pie cuts that I was telling you guys about a little while ago. See? There they are. They're just hanging on the side right there. That's why the skate shop was sold out of wheels. Wide Peepo Bay is almost done. There's the experimental dome on the left, and the old style bulkheads, or the current, I should say, on the right there. Truck. When do you expect the launch license to be issued? T-Man, I would guess 2 to 3 weeks, maybe a month at the latest. SpaceX wouldn't... Look, this is what I was saying before. They wouldn't be loading the pad with all this fuel. Elon wouldn't say about a month for Starship. You know, like, if he wasn't sure about the license, he wouldn't be saying that. He would, like, think about it. That's just how Elon freaking rolls, dude. Probability guy. He said Starship stack will be ready in about a month. He absolutely would not be saying that if he wasn't sure. But then again, I mean, there is Elon time. I understand, but I'm thinking that the license will take a couple of weeks to get that done right. Applying for a launch license is pretty easy. You have Space Policy Directive 3, one of the same space policy directives from the previous guy in the White House that established that. Applying for a launch license is not that bad. It's one-stop shopping at the FAA. Not deregulation, but consolidation of all the same stuff under one roof. So applying for a launch license does not take as long as the PEA, for instance. It won't take nearly as long because it's more of a routine thing. Now that I do know. That I'm damn sure about. But there could be something here because this is the first commercial spaceport or something. There could be something that does delay it, which is why I think Elon says about a month. Can I guess the location? That's Fiat's factory in Turin. Old factory in Turin, might I add. Can they still launch if they don't have 3 out of the 4? If they don't have like 3 out of the 4 mitigations complete? There's probably a comply date inside the programmatic assessment Novacon that says that they need to get these things done by a certain date. Now, my guess, personally, my guess is that they've probably already done most of the mitigations, because the SpaceX works with the FAA. SpaceX works with the FAA, dude. Like I said, it's not like a book report. SpaceX didn't submit their PEA to the Federal Aviation Administration and just sit there and twiddle their thumbs while they give them a grade. That's not how this works at all. You know, that's not how that works. Yeah, it's a pretty cool building, Bone Sister. I wish they still used it, but yeah, I think it's like a hotel or something now. So Nova, what I'm trying to tell you is that there's probably still some open stuff, some open ticket stuff that they still have to do, but the vast majority of things would be done already. Now, why do I think that? Why do I think that? Well, I think that because SpaceX knows that they want to launch sooner rather than later. So something that I've noticed that SpaceX does with paperwork and stuff is that they're very preemptive about it. This is just, you needn't look no further than like, okay, I'll give you an example. In September of 2021, or September of 2020, NASA modified the Human Landing System contract. They modified the wording on the contract, and SpaceX's lawyers picked up on that. They picked up on that. What was the change that NASA made to the Human Landing System contract? The change that NASA made to the contract criteria was that you could fund the project with your own money if you really wanted to. Now, you could basically match NASA, you know, as an investment, and you could fund the project out of your wallet, and you could use that to lower your bid. You could use that to lower your bid to an otherwise what's the word? A bid that doesn't make sense, like something that looks like an underbid. SpaceX picked up on that. Blue Origin and Dynetics, the other two people, Dynetics, a Leidos company, might I add. They didn't pick up on that. And then guess what? SpaceX got the contract. SpaceX is very diligent with their paperwork. They're very diligent. So if I know SpaceX and I know their legal department, they were probably working on mitigations since like January or something. Because remember, the programmatic assessment was already figured out. What the FAA has been doing is going and seeing whether their environmental assessment is up to par. That's what they've been doing. They're making sure that everything that they wrote down is up to par. So SpaceX was probably working on those mitigations basically since this whole thing started. I'll bet you money that they have. Anyway, look at this burb. Sure, Kuro, I suppose. Drone, squirrel, burb. Oh, that's cool. Did you see the hood close? Oh, that was cool. Watch. Oh, no, that's the QD moving. Hold on. We got to back that up. Watch. Watch the... So, right there is the umbilical, the fuel lines for Super Heavy. And then that's the cover. Because when this thing disconnects, that means Super Heavy's flying, which means it's going to get really hot right here. Not here... or here so much, but right here. There's going to be enough heat getting put through the air that it would melt a lot of things. So they have this big steel cover. Watch, ready? See that thing up there? Ready? Go. Clunk. That's pretty cool. What was the ETA that Elon said for a full stack? About a month. He said the second stack should be ready by August. That was the quick disconnect moving. I thought they would show it from another angle. Most of the mitigations are probably done. And just put it in the PAA to codify it for legal reasons. Bingo, Sorden. Exactly. That's what people don't understand. They think this is just some kind of book report, right? And SpaceX just got the grade back on their damn book report, and now they have to go fix things. That's not how environmental assessments work. Oh my goodness. Are they static firing Super Heavy before full stack? Now, Brian, I don't know. I don't know the answer to that. Maybe? I mean, if it was me, I probably would. Yeah, silly. Isn't that crazy? I love that United Rentals throughout, like, for like the past 5 years has just been like, SpaceX though, am I right? You know. Do we have a real-time comparison with the shuttle fuel line shutters? It's about the same time, Pythos, because Starship and the shuttle have very similar TWR, actually. Starship's gonna go, man. It's gonna go big. She's gonna go big. Like 1.3, 1.4, 1.5 TWR off the pad. That thing will be gone. Real quick. Like F-15 unrestricted climb gone. You know what I'm talking about? Like, oh, it's here. No, it's not. Okay. Not F-18? F-15 goes faster than the F-18. I mean, personally, if it was me, it'd be an F-4, but... So the Super Yeeter. Yep. Yeah, look at that. They're testing the chopsticks. I've been watching a series on YouTube. A sci-fi envisions the infrastructure for future tech. Cool. That sounds like Arthur Clarke, I think. Arthur Clarke? Is that that guy's name? I forget his name always. Super Stick. That's right. More like Dark... it's already in Texas. More like the Dark... nope, it's gone. Oh, you're at the Cape. All right, cool. Bye. Isaac Arthur, that's the one. I always got that guy. Yeah, Arthur C. Clarke is another. Yeah, but yeah, you get the idea. All right, guys. That's all I have for you for space news. Fellas, I hope you enjoyed it. Guys, I'm going to cut it a little bit short tonight. I'm going to call it now. I'm getting a little bit tired. I've been going since like 7:30 this morning. But I will see you guys. Actually, you want to know what I've been doing? I've been getting the cars and stuff. I got the Coronet fired up and running today. And now I got to work on the 59 because, well, I've been working on the thing on the weekends to try and get it ready for an auto show on the 26th. Yeah, the 59, the truck that's taken me 10 years to fix. I've been working on that because I want to get it ready for an auto show, but I'm going to be gone next week, so I have to get it done earlier. So, Stationeers tomorrow? Well, if I get some sleep tonight, dude, yeah, we'll do some Stationeers. I want to play Kerbal too, though. So, yeah, we'll see what we got. We'll see what we got. Let's see, who do we want to raid?